Start our recording. And so I will, again, like I said, first of all, welcome back. Um, Hope everybody had a chance to, uh, you know, play around with some things, check your settings, do the things that you might have run across since the last class last week. And also to find out if there's anybody that has any questions specifically that came about from that, then we can take care of those real quick. Or if not, we'll go ahead and jump into our second day. I'll go ahead and turn the video off on mine just to save a little bandwidth. And I guess we had been talking about points and point groups. Last we talked about how to make a group, how to use the points basically to respond to a request for a particular um, list of points to show which points we can. With many commands, we can reply with a group name, so it sort of streamlines what we're working on. So we'll spend a little time today. Let me make sure. Let's see here if it's what our agenda is. Okay, we're going to look at so we need to talk about a couple of concepts in terrain modeling and how we build terrain surfaces. So if you'll take a look in your books, if you have your training guides handy, you can look here on, I believe it's on page 18, talk about surfaces and contours and how we do actual terrain modeling. And there's really just some fundamental concepts and only just a couple of fundamental concepts that we need to keep in mind and we need to realize as to what happens when we go to build our surfaces. And if we can keep those things in our awareness as we are working with this data, and I'm talking about working with the data everywhere from even the times that you're out in the field collecting points, as well as when you're back in the office putting things together and you're trying to model what things look like out there on the ground, then if you just keep these few rules in mind, it's going to really help you to get a sense and an understanding of everything that's going on. This also feeds right into the field to finish philosophy and how that's going to apply for what we do. So starting here on page 18, we talk a little bit about what it is that we do when we talk about surface modeling or terrain modeling. And this is how we're going to generate contours. And contours are what we've sort of grown up being used to see on a map so that we know where our high spots and low spots are, where valleys and ridges are based on the way the shape of the contours and the way they are displayed and labeled. So we know that those contours represent a line of constant elevation along the ground. And unless you have been doing plane table and alidade surveying, which was done, gosh, back in the 30s, probably the last time, uh, in any kind of major way. We don't really go out there and try to find a specific elevation on the ground and then find all of the points that are also of that same elevation, but that was a survey technique at one point. where we go out there and actually try to walk these contours and then, plot their locations on our map table as we were in the field. So we don't really do that. We're not out there trying to find a specific elevation, but we're out there making observations of everything around us that might help us define that surface. And then we let the computer model that. And it does so in a process called triangulation. And there's a number of other different techniques as well, like gridded surfaces, which we're really not going to use those at all. Um, they're really almost at this point a very specialized way of modeling surfaces, particularly if you're doing things like, geologic modeling or mining, where you deal with multiple stacked surfaces. Uh, and you can get you can get the sense of what I'm talking about there, like in a mining situation, you'll have a strata of, say, limestone, and then underneath that maybe some more shale, and then maybe there's a layer of coal, or some kind of ore that you're trying to go after. And so you model all these points in there, and you want to try to capture each one of those individual elevations within that vertical stack that's underneath a single XY location on the surface. And so gridding tools has a lot of effectiveness in modeling those kind of things in a lot of our computations, but they're just not very accurate. And we're after the accuracy. With being surveyors, we need to see what this ground really looks like. So we're going to use triangulation. And triangulation simply means that we're working with a triangle. Okay, and if you look over here on page 19, it talks about this network of triangles that we are going to put together, and they are irregular in shape. And that's why we call these triangulated irregular networks, or you might hear the shortened term TIN for a triangulated irregular network. But basically what it means is that any given 3 points that lie close to each other, usually, will define a piece of a surface. So it takes a minimum of 3 points to define a plane in space. Okay. So, so that's what we're doing. We're modeling these terrains, is that we are creating all of these little triangles, and they match up with each other, with their neighbors, edge to edge to edge. And we consider them all together in one single set, and they form a continuous, unbroken surface by means of those little triangular patches. Okay, so obviously you're not going to go out there and survey every available possible square inch on the ground, but you're going to get some key points. Okay. And so the computer basically is going to use an algorithm called Delaunay's principle, which you don't need to remember or know anything about really. But basically, it's going to use that computational technique to look at every point that has elevation in your data set and look around itself to try to find the next available point that it can connect to and form an edge of a triangle. And what it's doing in that case is it's saying, here I sit at this particular point, I'm looking around myself, I see this other point, and I'm going to make the assumption that the ground changes between where I'm standing with my point that I've observed and the other point that I'm looking at, and the ground changes in elevation consistently between those 2 points. So if you look at this little image on the screen, you're saying if you were looking at, say, point 100, this point in the upper left with the elevation of 100, you're saying, okay, I'm going to look over here to my right, and I see this other point. It has an elevation of 110. So I know that at least based on my assumption, that halfway between 100 and 110, that has elevation 105. Okay. And it's evenly spaced between 101, 2, 3, 4, 5, 6, 7, 8, 9, 10 along that line. Okay. And it does the same thing with the next point it connects to. And if you look down to the lower left, you see there's another point down there with elevation 110. So it goes from 100 and it climbs up to 110, passing the 105 mark halfway between those 2 points. Now, if the land doesn't do that, if it has a dip in it or a peak in it or a little rise or something between the 100 and the 110, then we need to actually go and observe that particular point, that spot on the ground, so that we're saying it no longer goes from 100 to 110, maybe halfway in between the elevation there is only 102. And so now we've added an extra point in the middle. And so we're saying between 100 and this point in the middle, it goes 100 to 101 to 102. And then from the point here in the middle at 102, it goes all the way up to 108 by going to 103, 4, 5, 6, 7, 8, 9, and 10. So that puts in a little discontinuity between those 2 points. So our objective then, when we are out in the field surveying this stuff, is to gather up enough points that we can define this surface. And we don't need to get, thousands and thousands of points necessarily. We just need to get the points that define the changes in the ground surface. So if you've got a really even, and I'm not going to say flat in the sense of being level, but let's say it's an even, almost planar surface, like a large parking lot or something. Well, really, the only points you might need to get are the points, the 4 points in the corners. And then you would assume that everything changes linearly and evenly between each of those points. And if it actually does that, then that's perfectly valid. Okay, that will form a good representation of that surface. However, it's the changes and where they occur that we are going to try to model and to capture. And so right up here is this little statement that's talking about what we've just been saying, that every triangle edge that forms in a computer is understood to be a line of linear change or a constant rate of change in elevation between those 2 points. And if they don't lie along a straight line changing grade, then you have to separate them by some other observation. And if it's a linear feature, we call those break lines, or you have a sufficient number of points, additional points, to indicate lower or higher points in between. That's what we've just been talking about. So here's the first of the basic rules that you need to remember as you're doing this modeling. Is every point in the drawing that you are considering to be used for modeling, that every point can see every other point around it. And therefore, it can possibly form a triangle edge with any nearby point, even if it doesn't lie on a straight line change of grade. Then that would be a case that would be an error. But the rule is that every point can see every other point around it unless there is something in between that point and the other point that's going to act as a barrier. And those are what we call break lines, because they break the triangulation along that line. Okay, so and there's some nice, easy rules of thumb that are going to help us know when and where to capture these break lines. So here's what can happen in the computer. We don't really have any control over the order in which this happens. It's all baked into that Delaunay's criterion as to which points it's going to consider to join up together. So it sits on every point, it looks around itself, and when it finds a candidate point that it can use, it constructs in memory a line between the point you are currently sitting on and the point that you're considering. And it forms that as an edge of a triangle. And then it continues to look all around itself and connect to all the points it can find, unless there's something in the way. So in the case of this little image, if point number 100 looked around and it found this 110, well, it connects a line there. That was perfectly fine. It also looks down here below, it sees this 110, but it looks diagonally across to the lower right, and it could possibly have seen that elevation down there with or that point down there with elevation 100, except there's a line already in between. So in this case, the point, say down in the lower left at elevation 110, had already previously looked over and found this other 110 elevation point in the upper right and said, okay, I'm going to make that a edge of a triangle. So once that triangle forms in memory, it prevents this point with 100 elevation from seeing the point with 100 elevation on the other side of the line. So if you think of these break lines as being walls or barriers that keep a point from looking around and considering points on the other side of it, that's really the concept, because it's just as possible. If you look at this feature here now and consider what this ground looks like, I've got a point in the lower left at elevation 110, a point in the upper right at elevation 110, and then in the upper left and lower right, it falls off down to an elevation of 100. So this is a ridge. It's what we call a saddle ridge. We've got this nice even 110 elevation ridge. It falls off to the northwest at 100. It falls off to the southeast at 100. But those 4 points could just have easily formed like this. Same points, 100, 110, 110, 100. If the 100 sees the 100 first, it's going to form that edge, and now that's going to prevent the 110 from looking across and seeing the 110. So what does this patch of ground look like? This looks like a valley at elevation 100 that's sort of formed down here in the northwest to southeast direction, and it rises up to the northeast to 110 and also rises up to the southwest to 110. So that interpretation of these 4 points is just as valid as this one. So how do we know which one is right? How do we fix the data so that we're going to force it to make this a ridge of elevation 110 or a valley of elevation 100? And we do that by creating these break lines. We have to connect up all of the points that form those features, those ridge lines, the center lines of valleys, the edges of pavement, the backs and faces and tops of curbs, edges of concrete structures, anything like that, we need to make into these linear features to keep the triangulation from forming invalid uh, little subtriangles and concepts. And here is an example of something like that. If you look over here on this next page, 20, down in figure 3, here's an example of a curb along a roadway, and we've surveyed, all of these points, A, B, C, D, E, F, G, and H. It doesn't matter which order we survey them in, but if all we do is feed these points to the computer, well, here's a possible scenario. Point A can look over here and see point E and decide, okay, I'm going to change my elevation from A up to E in a straight line. Now that's invalid. As you can see, it doesn't pick up the fact that it goes down to the gutter line and then comes up to the top of the curb. It just assumes it goes straight up there to E. Same thing, C could look at G. C could also look at A and B. Now those are valid assignments because C does change evenly from C to B and from C to A. But B, for instance, could technically look up here and see point H or point F and just assume that it goes in a straight line up there, and that would be incorrect. So if it went from B up to H, for instance, it would, climb up through the air and then drill through the front corner of the curb and then emerge back here at point D. Obviously, that's incorrect. So what we have to do before we tell the computer to start munching on all this data is we have to draw the lines in between all of the points that are supposed to be connected. Those are going to be our break lines. And you can see an example up here of these are some of those invalid triangles that we were talking about, like A looking up to E, C to G, B to F, that sort of thing. But what we are really after is something like this on the right, where A can only connect to points C and B and any other points that might be off the image. E can only connect to points C and G and F because those do lie along planar features. Okay, so those triangles are valid, so we don't need barriers between them. And when we draw these break lines, let's say we draw the line that goes through points G and H, E and F, C and D, and A and B. So we construct those features. We construct that feature that lies along the gutter line, for instance, the face of the curb down there, the C to D line, and that goes all the way along the length of our structure. But so what that line does is it forms itself as a wall and keeps points on one side of it from looking over to the other side and seeing any other points over there. So B cannot see anything except A, C, or D. It cannot look across and see F or H or G or E. Now, point C, for instance, could not look up and see point G if we've got that line drawn between it. It can, however, look from C up to point D. So it can look along those break line barriers as one of the edges of the triangles because that's one and the same thing. It's forming an edge. And so if you're looking exactly along one of these break lines, you're not preventing something on one end of the break line from looking and seeing something on the other end of that particular line segment. Only think of these in terms of being walls that keep you from sitting on one side of the wall and looking across the wall and seeing something on the other side. And that gets us to the second rule of thumb, and really it's the primary rule of thumb. It's right here. These break lines that we are creating, whether we draw them in the computer after we've surveyed our points or whether we let the computer draw them for us through a process like field to finish, however we create those, what we're doing is we're drawing linear features along features on the ground, things that are edges on the ground, because that is their immediate break in grade is along that edge. So if you're walking along a nice planar surface up on the top of a hill and suddenly it breaks over and goes down a slope, and so we have a top of slope, that is the break in that grade. And so we need to connect all of those top of slope points together to make those into a break line. And that's the rule right there that I have highlighted. If it's an edge on the ground, then regardless of how we do it, we need to make that an edge also in the data before we triangulate it. So if we make it an edge, it becomes a break line. We don't have to do anything special to say, hey, this is a break line. It's just if it's there, and if we use it in our modeling, if when we say triangulate and contour, and then it's asking us to select the points and break lines to model the data, all we have to do is just simply select the line. So the fact that it's drawn at 3D elevation and in 3D space, it becomes a break line just by its existence. There's nothing special we have to do other than select it, okay? So that's really the essence of terrain modeling, is we've got points that we observe and we've got break lines that we create between the points, okay? And so another couple of things to consider is, exactly what are these surfaces, these planar features that we're modeling? And they can be anything. In our world, it's elevation of the ground. But it could be anything, like you see there, population density, temperature variations, any of that kind of stuff. That is a changing set of points that are potentially closely related to other points around it. So that's what we're modeling. So, we don't need to worry about things like temperature variations, et cetera, but we've got points and point data. And so this section here talks about some various other ways of getting data to model a surface, to turn that into a 10 or a triangulated irregular network. It could be a list of points, like you see there in figure 6. It could be spot elevations and break lines, maybe compiled from aerial photogrammetry, like you see there in figure 7. It can be things that we survey in our field work, and we bring it back in our data collector and bring it to the computer. That would be, just another form of getting a list of points in the computer. And so, once we have those points in, then we're going to run the commands. Triangulate and contour is the actual command that we're going to be using. But before we do all that, or before we accept it to be valid, then we need to sort of look at all this data and make sure that it is in its correct form. So if you take a look at these drawings right here on these 2 pages, the plan view picture that you see in figure 7, you see a road outlined in heavy black lines going across the top, and then you see a driveway that comes off of that in the orange color, okay? And that is the same thing if you look over at figure 8. That's this intersection right here along the main road and this driveway that comes up this little hill and then back down around with the turnaround circle around that hill, okay? But if we're looking at that in plan view, we don't have any way of knowing that that driveway line work actually, goes up and down and follows the ground. Same thing with any of the roadway work at the top. And right over here is the figure 9 shows an example of what you might see in a data set if it comes from somebody else, or if you didn't capture the elevations. You might see all of these, all of the break lines here were actually compiled up in their 3-dimensional location, but the road edges and the driveway edges and the stream center line, they were all just done in plan view down as 2D points. Well, if that's the case, they're not going to be very effective in helping me look at this data and say, looking at this point here on the west edge of the driveway, to keep it from looking across over here and seeing a point on the right edge of the driveway because there's no elevation information. And actually, though, if I have a switch set a particular way, that that driveway edge, even if it's drawn down at 0, what it will have the effect of doing is saying, okay, you can sit here on the left, you can look across to the right, but you can't see that point because I've got a line in between, but that line's down at 0 elevation. So the point on the left is going to dive way down to 0 elevation. It'll then look across and see another point along this edge at also at 0 elevation. Then it's going to climb back up and find this other edge up here at the true elevation of the ground. So if you were to do that, if you were to use figure 9 data, you can see the points that are starting up here on the ground, they're going to all dive down and try to hit these features down here at 0 elevation and then climb back up. And you're going to have a real mess on your hands because that's not the way the ground works. So we have to look at this data and make sure that it's acceptable for what we're trying to do. And right here, you'll see these things stressed throughout here. We're going to evaluate, 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 and our best option, the best tool that we have, use your own eyes. And we're going to talk about and learn about some tools to help us to do that. You already saw some of the things that we did with the points where we would spin the drawing up, but we got some really good tools in our 3D viewer. Okay. And so once we've established that, then we're going to look at things like this. And you can see these purple edges in figure 10. Those are all of the edges that form. So if I sit on, say, let's zoom in here, say this point right here, you can see the sort of a hub as a point, and it would then look all around itself and it would start to connect up to all of the points that it can see unless there's something in the way that keeps it from looking across there. And you can see that, for instance, if you look over here, look at these, right here's a little driveway entrance, but look beside it at this big point here that's the center of all these triangles down here. If I look at that and look at all the lines that come out of that point, and they go up here and they stop right along that black edge, that's another one of those break lines, and it's every point that it stops at along that edge, there's a point, there's a vertex in that 3D polyline that it's finding and stopping. But it can't look across that line and say, go way up here to the top and see a point up here. However, the points that are out here, say on this far edge, the points there, they're looking around themselves and you can see, they're looking back here to the south and to the east, and they're finding all those points, and those are fine. But there's nothing in the way that keeps that point from looking way up here and finding this point. And in fact, that's what it does. It makes these long, skinny triangles out here in the edges that are really not valid. Because what this says to the computer is that the ground changes linearly from this edge down here all the way up here to this edge along this long, skinny shaped triangle. And we just don't know anything about the land out in there. It's invalid. There's nothing there that we can say about it other than we know these triangles are not necessarily valid. They're not necessarily invalid, but they most likely are. And so we need a way of keeping these outermost points from looking across and hitting these other outermost points. And that's going to bring the concept of a particularly special type of break line called a boundary edge or a border. And so we're going to need to draw a line that connects all of those outside points into another edge that keeps those outermost points from looking across the gap and seeing the points. And you can see that as an example down in here. If we did not put a boundary line in here, a border around this little curved area, all the points down along this edge climbing up the left side of our data set, they can look across and see these points way up here in the upper left and start forming those long, skinny triangles. Same thing down here. These points in the lower right corner can look across way over here to the left and see all of these points and start making, you know, these skinny little triangles around there. So that's another concept of a particular type of break line we're going to want to use is a border or a boundary around our data. Okay. Now you may notice when you have data, let's take a look at, say, up here on the upper corner. If I'm sitting up here and I'm looking around, all around, all around, all around, trying to find other points to connect to, if there's nothing out here for it to connect out here on these edges, you see, it's not going to connect anything. But if there was a piece of this data set that went jutted out here to the right, then it can see those. So like down here in the lower right set of points, it can see all of these points all along the way. And so it can form triangles, even from the farthest left point all the way back to the farthest right point. It can form those long, skinny triangles through there unless we tell it otherwise with a break line or a border. And so the shape that I want you to get used to seeing is that the only time you really need to worry about that particular thing is if your data set is concave, if it juts to the inside, like you see on this curve here, and like you see across the bottom, it cuts into the main data and sort of has a little scoop out. Just like up here in figure 10, you've got all this data that goes to the north, all this data that goes to the east. And so that, but it comes around the corner and it's missing data in that little scoop out. But if you had points in there that everything went outward, if it was all convex, then there's nothing for those points to connect to outside of it. So it doesn't really matter in those areas, like up here in the upper right. Okay. So nothing you have to worry about remembering as long as you get into the good practice and a good habit of creating a border or a boundary when you're doing the work. Okay, so we're going to take a look at, and this will basically be this exercise of adding break lines on page 25. And we're going to take a look at what this is going to do for our data. Here's another view of that data. You see that cut in corner. That's part of what we need to control. This in the upper right, there's that, it's not a cut in corner, it's an out corner. So that doesn't really make much difference up there. But our job is going to be to model that, and we want our triangles to then cut off along those edges to be able to model this data successfully. Okay. So, so let's go ahead and start up our Carlson. If you haven't done it already, we'll go ahead and load it up. And we're going to load a file from our data set, if you remember where you stored your data. So once we get started, I'm going to open this file. And it's going to be in our 2024-02-22 survey class. That's where I put my data in a folder called data sets. And I want to look at this file called sample from T3 Global. And I'm going to open that file. You may have already looked at some of these and seen them. Now, what this file is, there's a company here actually in the Pittsburgh area called T3 Global Strategies. They are an aerial mapping firm. They do photogrammetry, they do drone flights, remote sensing, all of that kind of stuff, but primarily, everything from the air. And they do that for a lot of engineering firms. So this is an actual job, an actual piece of property that's about in the mid part of the state, or about midway down the across the Pennsylvania Turnpike, and it represents the ground that's out there in that area. Okay, they did this job actually for the State Highway Department, for PennDOT and the DOT, Department of Transportation, and then PennDOT's going to take that data and then use that to design some improvements to this intersection, presumably, or whatever this might have been for. But right now, as we're looking at it, it looks sort of familiar. We see some contour lines. We also see these white lines, these white outlined areas, and those are actually the break lines in the mapping. Now, when T3 Global made this contour map, they didn't draw the contours. They didn't create they let the computer draw the contours. The part that they drew, in fact, I'm going to go to my view menu and I'm going to freeze these particular layers here for the contours. This is what T3 Global actually put together. These they're the break lines in white. Oh, I'm sorry, I've got two more to do here. These are the obscured triangles or obscured contours. Yeah, so this is what they put together. They looked at their aerial photographs and they, put the little line down on the ground and traced out the edges of the tree lines, all the edges of the building, the edges of the road, the center line of the road, the edges of sidewalks, the edges of curbs and ramps, the edges of walls. And they compiled all that stuff in three-dimensional space so that when they put that together, and it looks like this, I'm just going to spin it up like so, you can see, like right in here, there is you can see that retaining wall, that loading dock in that area. You can see out here in the road, these, see these, trying to see these structures like right here. There's see that raised retaining wall that goes around the curb there, and you can see these edges of these curbs down here. And you notice how they are drawn at their proper elevations. Here's another loading dock area with a retaining wall. Okay, you see how that rises up and falls, and there's some other features like head walls and pipes. Now they do have an error condition down here. That's part of the data that we would normally fix. But you can see in general that was supposed to have been a head wall, as the culvert comes under that driveway entrance. Okay, so and over here, say a detention pond and a larger pond, a little smaller perched pond, a little drainage sluice down the face of this bank. But we don't have any of that other data that you would have normally seen with these contours. But of course, the contours help us to visualize the data. That's what we're used to seeing. Okay, so, but the only thing that they actually put together and I'll go back and freeze those layers again, were all of those 3D, well, be able to get it, there we go. All of those 3D lines and points. There are some points here that you may not see. Now notice there are also some 2D elements that they've put together down here on the ground. And those are just done for one particular reason only, and that's because AutoCAD cannot make 3D lines show up with a line pattern like this streamline that you see here that looks like a line and 3 dots. Any type of a line style has to be 2D before AutoCAD will actually let you see it. Everything in 3D, it resorts to being straight line, continuous line segment. All right. So they use that 2D stuff just to do the mapping, to do the drawing, but everything that goes into making this surface that creates the contours is contained right here and nothing down below. So it's only the stuff up here, and you can see there's some little pink dots in there. Those are the actual points. In fact, I'll turn that on so you can see them a little better. I'm going to come down here to my settings menu, and I'm going to go to my IntelliCAD settings, and I'm going to look at point style, and I'm going to change that to use this X shape so you can see those points a little bit better. Okay, so when they were putting this stuff together, they were looking in their instruments on this stereo imagery, and they were putting a little spot on the ground and saying, boom, record that point and its elevation, that point and its elevation, that point and its elevation, and go along this edge of concrete or asphalt, whatever it is, and start to, put all of these things down here at their proper elevation. And they do all that very rapidly, of course, much faster than we could survey it out in the field. But that's the entire same concept. They got a bunch of points, they got all of these edges, and they're saying, okay, now take that and create the contours from that. Okay. And then what they would typically do, or what you, if you received this data, might do, is that you would normally come in here and actually, as a finished map, you might want it to look like that. So you just see the contours, a few selected spot elevations, but all of that other data that went into making this is part of that model, and they're on a layer that we just froze so that we're not looking at that data. Okay. So now, do you folks you ever get survey file or mapping files, let's say a drawing file in um, from other surveyors, like other private company surveyors that you have to work with? Um, or do you always do your own field work? Okay, not sure. So, well, if you are ever dealing with survey data that comes from somebody else, a lot of times, and a lot of engineering companies, in my experience, where I've been working with these engineering companies for several decades now, a lot of these people will get a map in like this from a surveyor, from an outside company, not their own work. And they'll look at that and they'll say, oh, okay, that's a great looking contour map. And I need to make an existing ground surface that I can use as my design base. And so they'll they'll do the commands that says, okay, I want you to look at all this data and make a terrain model out of this data. But the only thing that they're looking at when they're doing that is right here, these contours, because they don't use those break lines that have been provided in this case. Sometimes the surveyor doesn't give you that. And so all you have are these contour lines, say, to build a surface from. But here, this is a huge source of error. If you ever try to build a surface from a contour map or from contour lines, the error that can happen is this. If we are building triangles, so let's consider we're sitting at every one of these little vertex points, and we're looking all around themselves, and we're finding other vertex points. Let's look at, say, this side and this side. And if I'm sitting at this point right here in the middle, where my cursor is moving, and I look around and I look up, I just look around in a circle, and I look over here and I can see this point up here at this contour line, and I'll draw a triangle edge from that point to that point in memory, in the computer memory. And that's perfectly valid because we're saying the ground changes from this line of elevation, this contour line, down to that contour line linearly. It's an even change. So halfway in between is the elevation that's halfway between those two contour intervals. I look around over here, I see this point. That one's fine too. We can draw that triangle. I might look over here and try to see these other points, but they probably already have triangle edges formed from some of these other points down here. So I just don't know it. I don't have any control over it. I cannot look past this line to say, see points up here in this lighter colored index contour. So that serves that purpose. It becomes a break line. But I can look back now. Let's continue around the circle. I look over here and I see this line along itself. Well, again, that's a triangle edge. It's already formed by the fact that that's a line drawn there. So that one's fine. I look down here and I see these points to the south, and I can start to create these um, edges of triangles down to these points as well. So I make a few triangles along in there. Everything is good. But if I go to the next point, I get up here to the corner point. I look around, I see these points above, I see these points below, they're good. But look what happens. If I'm sitting in here, and if I look over here to the left, I can see these points. And so now if I start to draw a triangle point, let's say from so if I see oh, I know what it is. I need to be in plan view. So there we go. So if I'm working down here, now I just isolate these things. So if I'm working down there and let's say I'm on this line here, I'm going to go up here and start forming triangles. All right, so these are all good. And we have some more back here, for instance. All right, so you get the idea. But when I'm sitting here, if I go from here, and I'm looking around myself and there's nothing that tells me that I can't do this, I may start to do something like this. Okay. So what does this say in terms of, let me draw another contrast for us here. So if you ignore this light blue line here for just a minute, what we're saying with these red triangles that formed is that, and let me go back to get one more. Okay, so if we look at the triangles here, we look at these up here in the on the far right that go between the contour lines. Those are valid triangles. Those represent the ground correctly. And if I look here, this line that I've just crossed, this edge right here, goes from the point on this contour up to the point on that contour. That's valid also. So is this line because it goes from the point on this contour down to the point on this contour, and there's nothing in between. But look at this. I'm saying that this ground goes from the elevation at this contour over here to the elevation of this contour and back to the elevation here and here and here. But this is one constant elevation. So these triangles in here are going to be what are called flat triangles. And so we're saying, let's say if this is elevation, say 100, and this is elevation 90, then we're saying if we do the triangles like I've drawn them here, these red triangles, we're saying, okay, from right here at the corner of right here, it's at 100, it goes down to 90. So halfway in between, we should expect that elevation to be 95. And in fact, that's what those contours would look like. And we go from this elevation of 100 down to this elevation of 90. And we're saying, well, we should expect halfway down, if you look along this blue line now, about halfway between, we should expect that elevation to be 95 because it goes from 90 to 95 to 100 and everything in between. But if we don't have that line drawn in there and it lets these triangles form across this gap flat, these triangles are exactly the same elevation. They're 100 all the way across. So the elevation that goes from the tip of this contour to the tip of the other contour stays at 100, 100, 100, 100, 100, and then jumps down to 90. So what that looks like in profile would look like this. It would come across at 100, 100, 100, and then suddenly drop to 90. And then it might do some more like this and then drop again. Now, this is in profile view. Okay. We'll see that again in a minute. And so that's not valid. In fact, what it should look like is it should go from 100 to 90 to 80, so that halfway in between is your 95, halfway in between here is your 85. And so that should be the shape of that little ditch line going down here. Instead, we wind up with it looking like stair steps. Okay, you may have seen that in some of your in some mapping that you may have looked at either from other people. So um, the uh, the bottom line of what we're talking about here is the importance of creating or using break lines if you've got them. In the case that this came from T3 Global, they provided those break lines, and there they are. And so there you can see, in fact, that line right there goes down all of these different little features. It went down the edge of a road. They didn't care about the contours because the contours were the output of this model. It was not the input. They didn't have the contours and say, make a surface from the contours. They had all the data that defined the surface and said, make the contours from the surface. And that's really what we're after. And that's what is going to be done um, to model this most correctly. I'm going to set my point style back to my default of just a little dot. I just wanted you to see that they're there. Okay. So again, how do we look at this data to be able to model it? How do we tell if things are shown correctly? Like we might have maybe there's an error, let's say up here in this curb line. I'll artificially create an error here so you can see it. And let's see, it's going to go there if I'm 13. So so I've made an error in this data. And to be able to see it, if I'm looking at it in plan view, I can't tell that I've put a big boo-boo in there, can I? But if I look at it in 3 dimensions, I can quite easily spot some problems. Okay, so I'm going to now freeze off these contours again just to get them out of the way. And I'm going to take a look at that data. Now watch up there what happens when I spin that up. Look at that. Oh, there's my error. You see, I come along here, and then I drop down to 0. And I go 0 to 0 to 0, and then I shoot back up here to the top. Now, again, in plan view, I don't see that, right? So to be able to fix that, I need those elevations to be correct. Now I'm going to undo. I think now I've fixed. Nope, still haven't. Yep. All right. So I've put that back now to where it needs to be. And those are some of the ways that we're going to be able to tell it is just simply using our eyes. We're going to look at this data in 3D. And you can do that any way you want to. What I've been doing here so far is I've been holding the shift key, pressing and holding the wheel on the mouse, and just pushing the mouse up and around to sort of spin it around and look at it and see whether things look correct. And they look fine to me in terms of what I'm expecting to see, like these edges of curbs and these retaining walls, things like that in here. Okay. So all of that stuff looks good. I would say, use that. There are actually some other subtle errors in the data that, that really ought to be resolved if I were going to model it from that to begin with. But we might be tempted, as I said before, to treat this as the data because, wow, look at that. It looks really good. Looks like it made a nice surface, but that's the worst possible data source because you're going to wind up with all of these little problems with these flat triangles in here if we don't have those break lines. Okay. Same thing over here. You know, we look at these contours along, that was that little retaining, that loading dock, the retaining wall. You can see the contours here come down to this, they come across the top to right in here's the top of my slope, and then down here's the everything along the bottom of the wall down here. And so, you know, it looks like that. It looks good in terms of our understanding of what those contours do, but mathematically, if I were to make a surface out of that, I'll show you one real quick. I'm just going to triangulate and contour. And I'm not going to draw any contours. I'm going to just select this file and we're going to call it T3EG1. And let's see what that might look like. Or zeros, no shrink wrap. Okay, everything's good. Here, I'm just going to select this data and now what happened? If I selected my data and I triangulated and it came down to my command line, let me open this up a little bit so you can see. See, it says writing the triangulation file T3EG1.10. And there are people in the world out there that we have to deal with sometimes in my industry that are training this software. They'll say, oh, here's how you make a surface. You just select all these contours. You can see now your surface. You made a surface. Congratulations, you're done. But you're not. You're done, but you're done incorrectly. And here's what I'm talking about. If you look at that surface, here's what it's going to look like. And it would look like this in triangle mode. And you see some of the triangles look okay, look fairly decent. But see all these over here? We talked about those long, skinny triangles because points along this edge can look way up here and see points along that edge. And I've also want to point out some triangles down along here. These are flat triangles. I can't really see it looking at it like that. I can see it a little bit better like this, but I can see it even better if I go to my view control tab and I color in my solids and look at that. Those are those stair steps that I was telling you about that you get down those edges that should have been modeled nice and crisp from the break lines. Okay. Look over here is another big problem. Remember that was supposed to have been that loading dock retaining wall. Well, good gracious, it shows as, you know, because there were points out here that could see points up here. And so it formed, you know, this big giant ski ramp, you know, it might be a nice handy way for a loading ramp that you can take a wheelbarrow and push your stuff up to the top, but this stuff is just a mess. Okay, it's not very valid. Look at all of this. Should be a nice crisp edge that you'll see here in just a minute. And don't worry, we're going to go back to you're going to do some of this stuff yourself as well. So the alternative to that type of modeling, even though the contours look really nice, if I try to build my surface from contour data, those are the things I have to watch out for. And if I don't have anything else, then I need to take the time to create these lines. And I'll just show you really quick what I would normally do. Oops, me. Just in one area here. And then I would turn that into 3D. I'll make sure I've got everything by viewing it in my viewer. And yes, I've now elevated that. So it's going to go all along those points and it's going to keep triangles from forming across those flat areas. I'm going to run triangulate and contour again real quickly. I'm going to change my file now to be EG2, existing ground 2. And just with the addition of that one little break line, notice it gave me no errors, told me I've got everything done here. So I'm going to go back and look at this surface now in comparison to the previous one. And if you remember those stair-steppy looking contours along that edge of the road, see, just by putting that line in there, I've smoothed all of those out. I would see the same effect on the other side of the road had I done that over there. So again, if all I've got is contour data, then I need to put these in, not just here, but all along everywhere I can recognize features like that that I need to restrain or constrain to a particular shape. Now, that being said, we do have a couple of tools. And just to introduce those to you quickly here as well, I'm going to make a third one now. And I'm going to turn this on down below. I'm going to, you see where it says this whole block in this dialog box down toward the bottom. It says adjustments for source data of contours. That's what I've got. Worst possible source data I could use. But I'm going to say, go ahead and use that. And I want you to minimize flat triangles. Now, what's going to happen? It's going to do the same type of thing, but it's going to try to, when it sees all of these adjacent flat triangles, triangles with the same elevation, it's going to try to reject those and retriangulate in that area so that when we look at that surface, it's going to try to fix that as much as it can. So you can see, at least on this left edge, it did a pretty nice job. It really sort of missed it on the right edge. Okay, so keeping in mind that that is a technique, it's far from foolproof. The best way in the world, and you can look over here, we still got these giant loading ramps and crap going on over here. So the best way in the world to do this kind of data, if all you have is contour data, is to take the time to draw the break lines down those features. In a case like this, that's crazy, days worth of effort. So what we would do if we had brought all this data in from the field, we would know that we shot these points down here along the gutter line. And, we would need to say, connect all those points together from our field points before we generated the contour lines. So alternatively, then, what we really should do, instead of taking the data from contours, and again, remember the contours were the output, not the input. And notice here with just this little bit of 3D line work as my source of information, we'll make one final one here, 4. And I don't need to use this anymore. It's there if I want it. And I can even do some things up here to, I'm going to turn off, I'm going to make some limits on those triangles that sort of artificially will create some. Now I've got some edges here that have some, I've got a couple of problems. I've got a vertical edge, 4/100ths. There's a little crossing break line in there. Here's one that's actually 3/10. That's that head wall that had the problem. Okay. So I'm going to just ignore those little things right now to show you the difference in quality in these surfaces. So if I now look at my fourth surface, I see some areas where I've got some holes in it, and there's a reason for that. Let's go back and rerun the model. And that was, I told it any interior triangles over 50 feet to throw away. So I'm going to change that up to 100 and make my exteriors, let's say 30. I'll keep the same file name, my data. The error box, view my surface now. Now you should see those filled in a little better. Okay, so there's a couple of triangles there were outside the limits, but look at the difference over here. Nice crisp edge down the left, nice crisp edge showing the sidewalk down the right. Look at those curbs. Look up here at these retaining walls. Look at all those things that, remember, before were just a jumbled mess in here. Now I've got well-defined curbs. I've got this retaining wall. I no longer have that giant loading ramp that sort of formed down here between contours. Okay. So just being aware of the quality of the data that's going to form our model is going to give us more accurate results. Now, all of that being said, there are some trade-offs. So sometimes, and I'll turn these off, maybe all you have are contours. Okay, you don't have the 3D line. Maybe you got this in from a surveying company and all you've got is contours. Now, if you're going to try to model some improvements to a parking lot and you need the curbs, you need all this information as part of what you're doing, then you need that higher accuracy. But if all you're doing is trying to get a sense of, where does the water go when it rains? And I'm looking at this, say, you know, hundreds of acres or hectares or whatever it is that you're using
And
there, the islands.
hello.
Uh, yes, James,
And
good
sorry for disturbing you, but
morning.
I just wanted to touch something with you.
Okay.
We usually don't do too much with the contours. It just might be if the client needs them, maybe that's when we'll generate it for them. So
Mhm.
I was wondering, is there anything else we can do apart from the contours? Because it seems too detailed for us.
Oh, sure. Yeah, yeah. I was just, I mean, you're like normally when you do your survey, your design work, um, and you bring these points back in when you're actually surveying these points, you're bringing those in with elevation, right? You're giving those to somebody to use as elevation.
Yes, but we use them as spot heights.
Yeah, right. And you would always still have those points as well. But
Yes.
so what I want you to start to consider and use and think about doing is when you have those points and you got those spot heights, where and when and how are those related and how can they help to inform, what you're doing? Because if I've got, if I observe a point out here in the field and I've got an elevation on it, and I observe a point over here, and I've got an elevation on it. What happens in between? Well, I don't know. I mean, let's do a better example. Let's, here's a really a good example. I ran into this in the city of New York once. Um, so they're doing, let me give that some weight. All right, so they were doing a sewer line. Okay. So they go out there on the ground, they know where they want to put the sewer, and or they know where they're going to put the manholes. They shoot that point, they shoot that point, they shoot that point, and they shoot that point. And then they'll draw a profile of the sewer line. All right, that's all well and good. Okay, right? But then something happened, maybe that comes along and said, well, okay, instead of doing that, we need to move this manhole up to here, and this manhole needs to come back a little bit to here. Now what do I do? Well, they had to go back out, send another crew back out to the ground and shoot that point and that point and that point and that point. Whereas if they had the data around it to form a continuous surface, then when they pick this, if they pick this up and just move it anywhere, it's going to read that ground and recreate the survey, the profile, the ground profile. They don't have to go back out there and reobserve these points because they've got that continuous surface underneath it. So, I mean, I'll back off on the complexity of this stuff, but I do want to give you a sense of thinking about this and where it's headed so that you can start to get some of that benefit from your field work. Okay. And particularly your field to finish, because all of that information is there. It's there right now. When you're the way you survey now, you're gathering that information. Okay, that makes sense. And we can,
Yeah, that makes sense.
yeah.
So
So,
if we
so
can
what?
look at it in that aspect, the way you've explained right now,
Yeah.
I think that would work.
Okay, good. So,
Yeah. Okay.
so yeah. And so and again, we're not necessarily going out there and we're not delivering this. We're not delivering these giant contour maps. I get that. But what it is that you can deliver is this, which is this mathematical definition of a surface so that whenever I need to put a sewer line out here, I know what that ground elevation is. I know what my cut and fill is going to be wherever I put it because I've got this continuous surface and everything in between the points that I've surveyed is interpolated. I understand that, but at least it's better than have to go out there and re-survey every time something like that changes. And that's really what we're trying to do with that. Okay? Make sense?
Yeah, I think now then the best thing to do is just show us how we can use the spot heights to generate
Yeah.
the surface. Then
Hmm.
we can use the surface now to be able to change in case there's any amendments on site. We don't need to go back and redo it. I think that would be the best way to go about it.
Yeah, exactly right.
Okay.
And again, so like I said, and this stuff can come in and wherever we're getting this data, um, we're gonna, like I say, our goal is to keep from having to go back out into the field to get this stuff every time something changes. All right. So that puts us at a really good stopping point time-wise, as opposed to last week when I ran your morning break, blew right through it. I was just trying to get through a lot of material. So we'll take our 15-minute. We'll come back at a quarter till, and we'll pick up from here. We'll talk about some of these controls. And I do want to kind of hammer home this 3D viewer so that you can look at this. And even if it's looking at surfaces or looking at just points that you've surveyed, just so that you can evaluate the quality of those observations in your work. Okay. and we'll see how those work. And they're not hard to do, just a couple of rules of thumb, and then you'll get used to using it as you work with this data. All right. So any particular questions to this point? Everybody good? All right, so I'm going to pause our recording. All right, so I'm going to open the file that you just sent me, which was this 37377 visit. And we'll take a look at what we got. There we go. Okay, so I've got some good information here. We'll make sure that we are where we're supposed to be. 153 600 or 6990600. Yep. All right, so we're in the right coordinate space. Do we have, let's see, I'm gonna look at the drawing setup. We're at a scale of 1 inch equals half a foot. Is that correct? What is our scale of this drawing? Looks like should be 1 inch equals 50 feet, or it's 1 to 500.
I don't think that's right. I don't think that's right. I don't know if it's still, but I'm sure you guys ready for that too, because you draw one in one. I'm sure these guys, when they pull the things in them, they're drawing at a scale. You know, so we don't really print at the scale. We don't really draw at the scale. Okay, so that's the thing.
Ken,
Yes.
apparently we mostly print it at that scale, but we don't draw it at that scale.
Yeah. So like right now, I'm looking at this bar scale here, and it looks like it's nominally would plot at 1 inch equals 50 feet.
Mhm.
Would that be correct?
Yeah.
Okay, so this scale value here, 1 to 500, is technically not exactly right. 1 inch equals 50 feet would be well, one inch equals 60 feet would be 1 to, well, 50 feet would be 1 to 600. Because there's 50 feet is how many inches? That's 600 inches. So it's 1 to 600 technically, but that part doesn't much matter. And the only thing that this does when I do this drawing setup and I set this scale is when I go to plot points and symbols, I want them to be the right size, like 1/10 of an inch here at whatever scale that I'm showing here. It's not going to change the size of the drawing. Everything's exactly on the ground like it's supposed to be. But like right now, if I leave it like it's shown right now, and if I let's just do I'm just going to draw a point here, and I'll just screen pick a point over here. And I'm going to call it just junk. Now, so now when I do a point, you see it's tiny. You can barely see it. Okay, so however, if I put this in that 1 inch equals 50 feet, if I set it up like this, I'm going to change this to 1. And let me make sure. Scale is on. And so now if I draw that point again, you see how it's now geared to be the same size as what you've already drawn. So that's really all that's doing with that setup. As we're saying, we expect to plot it at 1 inch equals 50 feet. Says English 1 inch equals question mark feet. So that's that answer right there. 1 inch equals 50 feet. And then that would size everything for me accordingly. Okay. Now, let's take a look at what we have in our data set. There's a couple of things we're going to do. I'm going to select everything. And I'm going to go to my view menu. And I'm going to look at my 3D view drawing viewer so that everything that has an elevation is going to show up. For me, and I look like I've got so I see there's basically the drawing, there's something somewhere way down below that's, let me see if I could just grab, if I just grab the data. There's still something somewhere way out of space here. Let me
The
see.
drawing ain't that 3D, man. You guys have to, the points, you're not reading the points. That's the thing, the points, I don't know what you do with the points.
So there's something way down. There's something way down out of range here.
And
No,
so
the base station, it would show up as a point with an elevation. It would be very, very far from the location of the survey.
I think it'll be a station, man.
Yeah, so if I,
Don't make sense.
yeah, see, there's some things over here.
The points, points, that's how the
Okay. I don't know.
yeah, the points are there.
Yeah, but I want to just basically look at, let me I'm gonna isolate.
Yes, the points, I don't know, cause normally, I don't know if it's on a turn or layer that's turned off, that's why you're not seeing the points.
The point layer should be off, because normally put an off, right? The point layer is always off in that,
Yeah,
right?
there we go. So this is everything that we've got that has elevation, and I see that little, looks like a double arrowhead, and it's sitting at some elevation as well. And that was this feature right here, which is on a layer called point elevation. And you see it goes from a start point of 0 to up here, it has a Z value of 1/4. Okay, same thing as with this one. It's a Z value of 1/4 and it goes down to 0. So is that supposed to be like that, or is that, see, that's 1/4. Or is that all supposed to be at 0?
Yeah, can just delete it. I think it's a gate. Just represent something like a gate or something.
Okay. Well,
Yeah.
what I'll do is I'm just going to select everything, and we'll start it at 0 and we'll end it at 0. Okay, and so now it won't show up, even though I select it and I view it, it's going to not display, because I said to ignore 0 up here in my upper right block, ignore 0 elevation. So there's now the data basically that we have. Okay. And Let me put these layers back on. Now we have some other features. We've got some buildings. We've got this this track. And so those could be used. We'll see how we can use those here in a little bit. What is this up here? What is the CLE height 6 feet and concrete base? What does that represent?
Where? Like CLE.
CLF, I'm sorry, not CLE.
It's a chain link fence.
Chain link fence.
Chain link fence, okay. So that's really not defining our surface. That's just a planimetric feature. That's fine. All right, but we've got some things here, like see this concrete tank with these elevations on it? Normally, and see right now, it's just a polyline with, and it has an elevation of 7. So that would normally, now, and that's just a constant elevation of 7, even though you got a shot here at 6.9 and one at 6.4, 6.1. So, you know, we could model that exactly to follow those elevations. Here's another thing. That's an elevation at 6 3/4. Okay, the gas line. So we'll take a look at those here as well. One of the things too, I see you're using fractional data, like 6 3/4. If I look at my units command, right now we're saying use fractional display of data, and that's fine if that's what you want to use. But if you're normally using like 6.25 feet instead of 6 1/4, you should set that to decimal. Okay, so that would be.
Then let's say after. You know how you think so that this, no?
No, I don't think so. No. I mean, it's based on the templates.
You have your set that this one, right?
It's based on the templates.
So now, one thing that you also sent to me, let's see, let me put this down a second, is let's take a look at that data here a minute. We have that CSV, the spot height CSV file, and that I'm guessing is your points. Can be imported. Yeah, so you've got points like this, and you see you've got a point number, a northing and an easting, and then an elevation, you've got 5.212. Okay, so that tells me that, you know, you probably should be using these as decimals instead of fractionals. So if we just run the units command, just type the word units and hit enter. Let's switch that to decimal, and then we'll put the number of decimal places up to 3 so that now we can see. And this has an elevation of 6.896. You see, I'm looking at that in my elevation properties over here in my left-hand panel. So 6.896, and that's a constant elevation of 6.896. And that may be okay, but it's, you know, it also has varying elevations according to those points that are around it. So, and again, we'll take a look at that here in a minute. We've also got these like gas lines and valves, and they're going to be, or that's a chain link fence, it looks like here. But you've got this as a gas line. Okay, so we've got a lot of different features here that could go into improving our terrain model. But we'll take a look at this in stages. Let's look first at just these points. And if I look at that particular point, I see it is a group. It's a block reference and a point. And so I know it's a Carlson point. So if I just double click it, I can see I've got a point here and it's 0.526 at this northing, this easting, and at this elevation, 6.243. And let's set our elevation down to 3. Okay, and then this is, like I said, this is just the point itself. Using that symbol, don't have any notes. There's no GIS data, no image, and set our decimals. There we go. Here's one at 6.1. All right, so we got a bunch of points. You've actually drawn them in the drawing. Now, I presume that was taken from that CSV file. That was your coordinate file that you used. You probably got that in from your data collector. So let's take a look first of all at that. I'm going to go to my points menu and I'm going to set my coordinate file. I'm going to make a new file and I'll call that one. What did you call that one? Like spot heights?
Yeah.
So I'll just use those same names. So spot heights. I now have a file, a new file created, but there's no points in it right now. If I list my points and I see that I have 0 points in that file. Okay. So I'm going to go to my points menu and I'm going to import some points here. I'm going to import a text or ASCII file. And it wants me to select a file. So I'm going to go out to my data set and I'm going to find that spotheight.csv. I see what it looks like here. And I'm going to say open. Now I see that I got a particular format. I've got a point number. And I presume that's northing, easting, and elevation and description. So the format I want is point name or number P, and they're comma separated. So Y is my northing, X is my easting, Z is my elevation, and D is my description. So that format is correct. I'm going to bring in everything by description. I think they're all G points. There are no header lines. I don't have like a title line here that shows me what it is. It's just pure data. I'll read all the points and draw locate points. I'm not going to draw anything because you've already got these drawn in the drawing. I don't need to redraw them in here. And I'm just going to say, okay. And it read in 456 points to my coordinate file. Now, if I look at that and list my points, here they are. And it looks like every single one of those points is a ground shot. Okay, and that's perfectly fine. And you can see the various elevations. I think I'm going to do that one more time, but I'm going to change the elevation decimals up to 3. And let's just put all of those up to 3 decimal places. And now you can see there's a little bit further data. Now, even if your points have 8 or 9 or 10 or 12 decimal places, we're not losing any of that data. That's just showing us in the report how many we wanted to see. All right, so I've got a good range of elevations. I'm going to make sure I don't have any sitting at 0. I think we're in good shape. Okay. I'm going to take a real quick peek at my file menu, my drawing cleanup, and I'm going to clear everything. And I'm going to say this one checkbox to set elevations outside of range to 0, but I'm going to choose scan drawing just so I can see. And I see right now I've got something somewhere that has a minimum elevation of negative 35,690. I've got something else that has a positive 203,858. That's my elevations in this drawing. So something somewhere is sitting at those weird elevations. Okay, that could be why we saw that when we first looked at the viewer, it was all sort of clumped in one spot and had those giant places somewhere else. So I know that my valid elevations are going to be somewhere between, like, do I have, let's see this gas line, for instance, if I've got, let's just text. Looks like everything has positive elevation except for those ones that were way down. But look at this. See, I've got something way down here. They're on a layer called C beacon name. And that's sitting down here at negative 32,808. I've also got, let's see, something probably way up.
Over the drawing.
So if I move this up to 0, well, that's just text. So if I set those here to 0, they're going to go up to 0. Now, do I have anything? I don't see anything up there. So I'm going to go back to my top view.
No, there's something there. Is it?
Now there's some things over here too that we've got that, we don't really necessarily care about. I'm going to go back to my drawing explorer. Oh, I'm sorry. Gosh, not my drawing explorer. Let me turn that off. Go back to my drawing cleanup, and I'm going to choose this set elevations again, scan the drawing, and now I still got something at negative 35,000, and it goes up to 203. So, what do is there anything in this data that might have negative elevation that's, real close to being like maybe a gas line that's under the ground? Like here's a couple of things, for instance.
10.
Yeah, so that's select one of those. See, that goes from negative 13,984 to negative 14,107. All right, so those may or may not be meaningful. I don't know for sure. Here's another one. And the tree line, and it has elevations of, there's an elevation of 23.6. It goes down to 7.9, 8.07, then up to 31,255. And that could be that, you know, it was shot on the top of the tree. Now that may not have any meaning for us. It might just be where we're going to show it in plan view, so we might not need to worry about it. Okay, so there's a couple of things like that that we need to sort of keep in mind that we might want to use and see. But let's see what we would typically do to make this into a surface so that if we need to put a, say, a water line or a sewer line through in here, we don't have to go back out and shoot those actual locations to get the ground elevation. We want to find out what the ground is in between all of these spots, right? So let's just look at these spots for right now. So I'm going to go to my view menu and I'm going to isolate layers, and I'm just going to pick one of those spot elevations. So now this is on layer spot height. This one, remember, we put to 0, so it's not going to affect us. We're just going to be modeling this as a surface. Now you see where all these buildings used to sit? Those are, right now, if we make this into a surface, we're going to interpolate the ground elevation in between all of these points as they go down, you know, as they go underneath the buildings, which is not really valid. And there's a way that we can resolve that in a minute. We'll look at that. But let's, for right now, look at what we do to build this into a surface. Now, remember, when we talked about building a surface, we said every point that it sits on. So let's say we're sitting on this point right over here. It's going to look around itself and try to draw triangle edges up to these other points. So it's going to see these up here above it, and those are going to be fine. But it's also going to look down below it, and it's going to look, say, to this point, and it's going to assume that the ground changes from there to there all along this straight line evenly. Now, that may be the case, but it also could mean that we need to put a border around this stuff so that it doesn't fill that in. Okay, and so that's going to be our first step right now, is to put that border around our data. And all this border is going to be is just a 2D polyline. And we can simply draw it if we want, but there's a quicker way. It's on the draw menu, and we're going to draw a shrink wrap around our entities. Now, don't confuse it with this boundary polyline. That's a different thing. That's from the inside out. This shrink wrap entities is what we're after. So we're going to say shrink wrap these entities. And it's going to come up here, and I'm going to choose a method across gaps so that it can jump across these gaps in between the points. And I'm going to give it a layer name. I'm just going to call it surf BDY, surface boundary. And I'm going to make it a 2D polyline. And I'm going to change its perimeter reduction. First of all, I'm going to say none to show you that effect. We'll say OK. And it says select the entity. So I'm just going to select all of my data. And there is the border that it would compute if I said no reduction. Notice it did not cut into this missing area like I want it to. Okay. I'm going to go to that border. What did I call it? Surf border, surf boundary. And I'll make
Ken,
it. Yes.
the self border that you just created, is it also going to act as a break line?
As a what? A grid line?
Break line. Break.
Oh, a break line. Yes. It will behave like a break line,
Okay.
but it's not a break line in the sense that I don't have elevations on it. but because it's going to be my outermost boundary, it can just be a 2D. Okay, so that's there with it as no reduction. Now I'm going to erase that. I'm going to repeat that command to draw a shrink wrap boundary. And I'm going to show you the difference in this setting.
Use the boundary. There was a boundary on it, so.
So now under perimeter reduction, which was set to none, I'm going to set it to high. And I'm going to say, okay. And I'm going to draw this around this time. And now you can see how it jumps in all the way around, including all of these inside points. Now, it could have, say, had we wanted, it could have gone, to look like that. Maybe that's actually more valid. And then maybe we should have, gone into this area a little tighter. Okay, so we don't know exactly what that's going to be, but that could be something that we do with it. Okay, so that's going to serve as the border that's going to limit, and this is another thing, we could, come all the way up into here. I don't know what's actually in that area. It could be okay just to leave it as it is, and then we'll see what happens. But this is going to keep those long skinny triangles in this gap area from happening. Okay. So if you shrink wrap border and set the perimeter reduction to high, it will form something like that. Usually what we do, though, because sometimes high is a little too much, if we draw that shrink wrap entities and set that to medium and say, okay, then you can see it's a little looser on how tightly it jumps in. See, it doesn't jump in like here or in here. Okay, so it just depends on what it needs to be. And again, you can do all that stuff manually. You can draw those things, just by drawing a polyline if you want. But I'm going to set this back to my high value. Select all my data. Let it go around here and now here. I'm going to tighten this up a little bit. So I want to add some vertices in here. So I want it to come inside this area. So what I need to do is to add some vertices in here. I think, let me double check something real quick. Yes, okay. See, there's nothing in there. There was no elevation information in there. So that's really not going to be valid surface data in here. So I want to add some vertices into that polyline. And you can do that a number of ways. You can simply select it, hover over that midpoint grip and choose add a vertex. And then you can, go to each of those individual points and snap your way around it. But that's, you just keep doing that one at a time. Or you can, let me make sure this thing is on, okay. Or you can do a Carlson command under Edit, Polyline Utilities, Edit Polyline. I want to add polyline vertex. Now watch what happens here. It lets me do it all without doing all those right clicks and stuff. If I select my polyline, it wants me to pick or enter a point. So I'm just going to draw my way around here. I think I'll jump down to this one and then to this one, to this one, to this one, back to this one, this one, this one. this one, and this one. Okay. So now I've added those. Ooh. I meant to. I wanted to pick up this point. I guess I missed that one. So if I add a point to there, I'm going to select this polyline and I'm going to add to that point there. There we go. Okay, so we could do a little bit of cleanup in that regard. Looks good coming around the outside edges. We've got all those outside points. We've got a gap over here, but we have points out here on the outside edge. So we've picked up all of the outside points. We might come in here to scoot this in a little bit further, but this should do us as a boundary, okay? So you should now have a boundary drawn around your data. And you've got the data showing that we're going to be using to create this surface. Okay, so let's do that next. So we're going to go to the surface menu and we're going to choose triangulate and contour. Now, this is a dialog box that's pretty heavy. It's got a lot of different things in it. And we're going to start over here on the selection tab. And this is where you can filter out what gets used in the surface creation. So if you said, I only want to use CAD points and Carlson points, but no lines, maybe 3D polyline, you can set a filter like that if you wish. But I'm going to uncheck that specify selection knob because I want everything to be selected. Now notice you could also, if you had done this like this, you could say from a file, and I could have gone straight to that spotheights.csv without even having them drawn in my drawing. I could have read the file directly. Okay, but I'm not going to turn any of those on. I've got the points in. We're going to use those. All right, now let's look at the triangulate tab, the contour tab, and the labels tab. Now this contours and labels, this is something that can be done at any point once you have a file. I personally don't draw my contours as part of this step. I usually like to create my file, look at my file, and then I'll go back and create the contours from it after I'm happy with the file. But you can turn that on to draw it all as part of this process, okay? So if I draw my contour layer, if I turn on draw contours, I want to choose the method. I'm going to contour by a contour interval. Notice you can contour a specific elevation if you want. Like if you want to find a flood limit line or something, you could do that. But I'm going to contour by interval. And I'm going to set, what would typically be your contour interval on this? Like just 1 foot? So a 1 foot contour, a 5 foot index contours, and then I would select the layers that those go on. Now you can just leave yours set to whatever default they come up to. Probably, I don't know, INTER and INDEX or something like that. Those are fine. And I'm going to not check any of these boxes up here. And I'm not going to turn any contour smoothing on. I just want to see what my raw data is going to give me. And let's go to the labels. We'll label the contours. And I'm going to come down below here and I'm going to choose to hide the drawing under the labels. I'm going to label the index contours only. I'll align the text with the contours and I'm going to draw the text at its elevation, draw on the real Z-axis. And the distance interval, let's put that at, say, every 250 feet. And I'll Now I'm set to draw my contours, to label my contours, and now let's look at the triangulate tab and see what we're going to use to build the surface. So the first thing I'm going to do is I could draw all of these different things. I don't need to. They're all going to be part of the file that I create anyway. But I do want to write this triangulation file. So I'm going to check that on and I'm going to hit the select button and I'm going to give this a name and we're going to call this one 37377-EG for existing ground. Okay, and I'll save that. Now, the next set of switches, use the inclusion and exclusion areas. And right now, because we drew that with shrink wrap, so since we have it, we're going to turn that on and use it. If we did not have it, notice built into this command is that command shrink wrap, and you set a perimeter reduction. You could say high, medium, low, none, and you could actually have this boundary draw itself for you as part of this command. You don't have to draw it first, but we did anyway. So we have it, we're going to use it. So I'll check that on, and I want to trim the edges at the boundary, not just remove the crossing edges so it takes out the whole triangle. We're just going to trim the triangles at that edge. And I will ignore 0 elevations. Also, above that, erase previous contour entities. I will say, yeah, whatever my current surface is, if I have to go back and change something, it's going to erase any drawn contours so they're not included in the data the next time I run the command. And that only happens if I run the command another time, as it erases them. So I will ignore my 0 elevations. You could limit the input elevation range to a certain value and the output, all of these different things that you could control. I'm going to right now set my triangle edges up to 2000 just as a number so that that actually won't have any effect because they're set to be very large. I could densify break lines. Now, I don't have any break lines in here, but if I did, that has the effect of adding vertices at a certain distance interval along each of those break lines. Well, I don't have any, so I'm not going to worry about it. I'm not using contours, so I don't need any of these. And I don't have any dense ground data that I have to worry about simplifying the surface. So everything's good to go right here. I'm going to say okay, and now I'm going to very carefully read the prompts. And it says, select entities. Well, you might be tempted to go around and just drag a window around everything and hit go, but that's not what it's asking for. Read the line above it. It says, select the inclusion perimeter polylines or enter for none. So it can be more than one. We only have the one, so I'm going to select that one. It says entities in my selection set is 1. I'm through selecting them, so I'm going to hit enter. And now, again, reading the prompts, it says select the entities. Well, you would think now I grab all my points, but no, not yet, because it's asking me to select any exclusion polylines. Now, thinking ahead a little bit, what we're going to do next is we're going to turn those buildings on, and we're going to select those drawn polylines of the building outlines to be areas that it will exclude. So it doesn't try to model the ground under the building. Okay, but we have none right now. We're going to just say enter for none. And now it comes back and it says select entities again. Reading the line above it, it says select the points and break lines to triangulate. Now we can grab everything that we see there. And you can just type the word all and hit enter, or you can draw a window around it, however you want to do it. So I've done that. I'm through selecting, so it's still prompting me to select entities. I'm through, so I hit enter, and off it goes, and it draws the contours. And you can see them right there. This is the contour elevation of 10. And you can see based on your spots, that's where that contour line goes. And here's a case where there was a 10, there's a 9.8 up to 10, and then here's a 9.9. So right in there, it crosses, this contour line could technically come up here and say, go around here and come back around. It's just the way the algorithm computed that contour line is the way it drew it. Okay, so that now is a surface. And you can see the contours, you can see what they look like. You can also see the entire surface. If you go to View, 3D View, Surface File Viewer, and let's choose the file we just made. We'll open that up. I'm going to double click the top so that it fills up my screen. And these are the triangles that would have formed. Now, let's learn a little bit about how to use this viewer. There's 3 tabs at the top, and they're going to have some control for us. But the first thing that I want to look at is my View Control tab. And I'm going to look at this block of icons right here in the middle. I've got this pan, the little hand, so I can pan the drawing and it doesn't change the orientation. I've got this one that says switch to rotation mode. And that's going to be the mode that we use most often, that we're going to use to be able to spin it around and look at it in 3 dimensions. These other ones, like dynamic zoom, zoom previous, those really don't have much effect nowadays because you have a wheel on your mouse and you can control that just like you do in your drawing. You had this arrow icon, which lets you point to a particular thing in here. And if you notice on the status bar, all the way down here at the bottom of the screen, you see where it's reading where your cursor is, what the slope is, what those distances, there should be an elevation. It's reading the X, Y, and Z right in there. So that's telling you some information about the surface. You've got clipping available where you can clip this stuff on and off. Those are these sliders down here. Clip far, top and bottom. So if you're rotated, near and far would be front and back. Top and bottom is always elevation wise. Okay, so there's that one. Then you have reset the view to plan view or reset the view to zoom extents. Those are the other 2 things that you can use here. Well, let's go back and grab this rotation icon and let's learn how to spin this thing around. So if you've got that chosen, notice the cursor as you hover the mouse. It changes from a Z with an arc arrowheads to an XY arrowheads. And that's going to be the control that's going to change our viewpoints. And if we go over here to the right, and if we make sure that that middle Y axis is locked, that's going to help us to quickly and easily be able to view this in any orientation that we want. And here's what I want you to visualize when you're using this. If you consider that you are, say, standing in your driveway and you're looking at this thing as, pretend that's your garage door on your house and you're standing in your driveway and you're looking at it. If you put the mouse over the middle part of the drawing to where it turns into X and Y, and then come down toward the bottom, click and hold the left button and push it up. Notice if you push it left, right, it has no effect, but if you go up and down, it raises it back. And, grab another chunk if you need to. What you're trying to do is you're going to raise your garage door up to where it's laid back, not all the way flat, but sort of obliquely like this. Once it's like that, let the mouse button up and then put the mouse out of that view down toward the bottom to where it changes into a Z shape. Now you're going to click and hold the left button and you're going to move it back and forth See, it has no effect up and down, but back and forth will spin that around. So you're going to spin it around and line up. Let's say we want it to look right in here along that roadway. So if I spin that around and look at that and I get it lined up the way I want it, now I can use the wheel on the mouse to zoom and pan, and I can reposition, sort of fine tune your way around it. But if you just remember those two things, pretend you're in your driveway, raise your garage door up, lay it back, and then spin it around, get lined up with what you want to look at, and then zoom in with the wheel and zoom back out if you need to. That's the essence of moving that around in your 3 dimensions. Now, the other thing we hadn't talked about yet is this little icon that says toggle shading of surfaces. It's the one that looks like this little fishnet that's all colored in. So if you click that and unclick it, you see what it's doing. Because we are looking at a surface, the surface is defined in between all of those little triangle lines. I'm going to go over on the settings tab now, and I'm going to check on to display the triangle edges so you can still see the triangles. And that's what they look like. And if I look down here, say, I presume that's a roadway, just by the shape of the data. You know, you can look around the edges and see, make sure that you've modeled it correctly. I can look up here and I see a couple of little things that may or may not be a problem. I don't know the data, but like right in here's a point that might be, you know, a little low, or maybe it's valid. You know, we'll just have to know the site and be able to work with that if we need to. Okay, and there's things you can edit. I go back to my view control and click on the plus mark. You can do these surface edits like removing a triangle, removing a point, adding break lines. You can do all that stuff inside this viewer if you want, but it's a lot more effective to look at it, see if there's something that caused a problem, go back out to the drawing, fix that thing that caused the problem, and rebuild the surface from there. That's the most effective way. But that's essentially it. Now, up above, also on the view control, you've got this vertical scale. So if you need to add some vertical exaggeration, I'm going to pull that down and go from 1 to 3. Or let's even go from 1 to 5. Let's put it up here to a 5-time vertical exaggeration. Now, that doesn't change the data. That's just exaggerating the relief so you can see it better if you've got a fairly flat site. Okay. I'll put that back down to 1, so it's what I'm looking at. A couple of other things, color by elevation. You can get a view of what that might look like in a spectrum of colors. They range from blue for my lows, green for my mids, and reds for my highs. And you can control those colors by going to the settings and hit the set colors button, where you would set those colors there accordingly. So, but these are good. And this is a real good way to visualize your data to make sure it's about what you're expecting. So you're going to look at the numbers on the left-hand side and see, okay, they range from like 4.2 up to 14.4, somewhere around there. You don't have any control over that interval or what the exact numbers are, but that gives you an idea. And if that looks correct, then that's probably pretty good. And it also should be a fairly even distribution. You see the low areas, you got the mid areas, you got the high areas. But let's say if you had a point in here somewhere that was way out of whack, maybe it was mis-surveyed, and it was, or maybe somehow or another the elevation got changed to be 100 feet taller than its neighbors, then you're going to see that stand out. It would be red all around that one spot, and everything else would be a weird color. So you want to look to see if there's a good even distribution of color. Okay, so that's a way of looking at your surface to evaluate whether it's good or bad. Another one on the settings tab. If you choose this pull down here, it says bounding box. You can say box only or box with labels. I seem to have managed to lock it up. Boy. Okay, there we go. So box with labels, and wow. I've managed to do, there we go. It's coming here shortly. Let me change that. It's wow. Let me see if I can get out of this and re-enter it. Anyway, what it would do is it would show you the range of elevations along the corners. And you could see, if you had a stray point, for instance, that was way too high, the box would be way up in the air and you just see that one stray point. And then you would know to go back out to your data and resolve that particular error. We got to try to get this. Resolve here. I don't want to kill the session, but I may have to. Let's see if I can't get it to trigger a change. There we go. All right, so I'm back out. Now I'll come back into that view. And there now is that box with the labels. Or I could have said box only. And so if you had a stray data point, you'd see that box would be really deep or really tall, and you know there's something in there. So this is a good indication that you've got a good surface created for for the data that we gave it. All right, one other thing in the view control, besides coloring in the triangles, and I'm going to turn the triangles off, you can also display the contours and even give it let's give it a 0.2 foot contour interval. So it can even, and it generates these on the fly in memory, and it would take, just to show you some indication if that's a way you can perceive your surface better. Now I look at this and I see there's a point right there that, might either I don't know what it represents. It might have a bad elevation. It might be something that we should not have used in the surface. Same thing over here. I've got, something that pulled all this stuff down in these corners. So you can, do a number of things there. I could even, let's say if I removed a point, and I double click there, notice what happens is it does it on the fly as I'm changing these. I'm saying, take that particular point out, take that point out right there, take that point out over there. Now I'm not going to save this change, but you see what I'm doing is I'm telling it what to use as far as the surface goes. And then if I exit the viewer, it asks if I want to save those changes. I'm going to say no, because I've got my surface right here as it's done. Now, one of the things we did when we ran the surface triangulate and contour command, and we said labels for our contours, and we said hide the drawing under the labels. We did not break the contour at the label because I didn't want to break the line physically. I'm just hiding under the labels. And what happens when you, oops, sorry, I got to go back and rebuild it now here. All right, so what happens when you do that is you get the ability to do this under the surface menu, under contour utilities, can move a label along a contour. So if I've got a contour label that's in an awkward spot, for instance, maybe I don't want to see this one here. I'm just going to click that and then select the text and watch. I'm not even snapping to anything. I'm just walking along that. So if I wanted it to be up there instead, I can put it like that. Here's one that maybe I wanted to put over here. Maybe this one, I want to put it back over to there. So you get the idea. It's just purely cosmetic stuff, and it lets you, be able to change it. Now notice it also will flip it if it needs to change its orientation. Okay, so that's another feature for you. So let's leave that on as it is, and then let's restore our layers. Let's go back to view, restore layers. And we've got, all of this other mapping, but we've got these contours that run through it. So I've got this contour line here that has an elevation of 8. And we're saying it goes up here, hits this building, goes underneath it, comes back out and around it. But really, we don't know what goes on under the building. So we should have given those building outlines as exclusion areas so that it did not draw the contours or even create the surface data underneath the buildings. Okay, and we'll look at that when we come back after lunch. Couple of things down here too on this. Oh yeah, Shamrock Road. So you see that's a road down there. Now, all these points, are these the edges of the pavement? Or is there a curb anywhere down there? I don't know what these points are. There's BC.
Center line of road.
I'm sorry?
Center line.
Okay, those are the center lines. And
Yeah.
these BC points are the back of curb, for instance?
No, the boundary beacons.
Oh, okay. All right. So I've got center line points, and what about these points?
Edge of the road.
I'm going to isolate. All right, so these points are all center line points. And then I've got these points over here are the edges of the road.
Yeah.
All right, so now, just to show you how that can improve something real quickly, if I restore my layers back, you see these contours, how they look going through here. Not necessarily indicating a road based on those contours. It could be okay. But if we do this, I'm going to draw in a break line all down, connecting all of those centerline points and all of these edge of pavement points, and show you the difference that that's going to make. And it's very quick to do. And I need this to be a 3D polyline that goes through all these points. Okay. So I'm going to go to draw 3D polyline, and I'm going to uncheck prompt for elevation and slope, because I'm going to let it read the point. And I'm going to put these on a layer called 3D BKL and 3D break line. And we'll say, okay. And now I'm just going to go here and snap to point to point to point. Now, if that were along an arc, there's ways to fix that. And we'll see that a little further on in our discussion. We can actually turn a 2D arc into this 3D element. But just to show you the effect that this is going to have on the triangulation, let's come up here maybe. Now, just that one difference. If I go back to triangulate and contour again, let's go to surface, triangulate and contour. And let's go to my triangulate tab, and I'm going to change the right triangulation file. I'm going to select, I'm going to give it a new name called EG-2. We'll save that. We'll say okay. And now the old contours turned themselves back on, but we're going to erase them. Let me see, why didn't they erase? I think because we changed surfaces. So if I repeat that, let's change that to all. So now I'm going to select my inclusion, no exclusions. And now I'm going to get all of my points as well as those break lines down there. And you can't really tell a lot of difference, but you notice that the contours peak right at that center line because it's crossing that break line as it goes along there. So there's a vertex point that gets established right there along that 3D edge. Okay. In fact, if we repeat that one more time, let's change our contour interval to 0.2. Now you can see a little bit. You see this edge, this edge is pretty well defined. This edge down here, maybe some of these, I don't know if that's, it looks like there's a, now don't be overly concerned. Those are just the red lines are just 1 foot apart. They're not, it's not like a 10-foot drop. So, there could be some things like maybe these points, I don't know that they're exactly the edge of pavement or not. But if those points had been by description, let's see. Here's a screen point. See, that's got a description of G for ground, and all of your points say G. Looks like everything got moved a little bit, but so really, when we're out surveying on the ground, if all of these points along the center line, if we had their elevation, or if we had that description, instead of G, maybe it was CL for center line. Okay, and then we could use field to finish this set. Every time you see a CL point, draw that line in there for me. So it would create all those points. All right, so I'm going to, I'm going to erase by layer. I'm going to select from the screen and I'm going to get the label, the index, and the intermediate, just so I can get rid of all those things. Now, we'll end up, there's some points that are not in the same spot. See, that one shows okay, but this one, you see this? It says screen point differs from the coordinate file by 2.85 feet. Does anybody happen to know whether those points got moved or not? Let's look at this point. Let's look at this point 11.7. That one's okay, but this one says it's 2.85 feet different. That's point number 1132. I don't know that that would be anything that we could recognize. 1132. So that one is the CSV file that you gave me that made this coordinate file doesn't agree with the drawing in some places. Like right there is one place. 2.85 feet difference. There's another one here. That one's correct. That one's correct. That one's correct. So there's maybe not terribly much. Maybe I just managed to find the one that was moved. I can't seem to find it. But anyway, that's the basis of how you're going to do that to build that surface. And then what that's going to do for us then is if we restore these layers now. If I need to, put something out here on the ground, like a water line or a sewer line or something, if I want to see what that surface looks like in there, I've got a surface inspector somewhere. Let me see here. Maybe not in survey, maybe in civil. I've got a surface inspector to let me look at those points. But I can now, let's say I wanted to put something along some pathway out here. If I go to my surface menu down at the bottom, I've got this profile section. If I use a quick profile, and if I choose a surface file as my source of data, I'll choose that first file that I just made. And I'll say, okay. And I'm going to just pick some points here. And I can see now up here and down here below in my profile, if I do just a one-time exaggeration, so it's not so scary looking. But everywhere I move along that, let's go to maybe a 2-time or 5. Yeah, so right there, you see where my crosshairs are in the profile view. You see where I am in the plan view. And then that's going to come down there to that. There's a low spot right in there, but there's a high spot right there. And it's not terribly high. If I turn my vertical exaggeration off, you see it's not much. But I can also do this with knowing what what the elevations are at every point along that surface, I can adjust my alignment. And I can pick this alignment up and move it, and notice the profile view is reading that surface in real time. So that's showing me everything that's part of that surface that we just built based on your points. Okay. And the one last thing I wanted to show you in this surface viewer that I started to and then got sort of sidetracked on the but part of these controls is this little doodad up here in the middle, the blue circle and the yellow square. If you think about that as being the sun, the yellow box is the sun and where it is in the sky. You see, as I move it around, if I get all the way down on the horizon, you see that's sunset right here in the middle is high noon. But I can move that around to help emphasize some of those shadows from different areas that can help you to visualize what's going on with your surface data. Okay.
Okay.
So with that, we're gonna take our lunch break here. I'll give you we'll get our full hour and a couple of extra minutes. So when we come back, we're going to look at enhancing some of this stuff. Like you've got some of these are like this is an arc right here as part of this running track. And I see that it has over here in my I see that it's got a center elevation of 6.285. So that is sitting at 6.285 feet in elevation. And if I look at this data in my 3D viewer, except I've got something somewhere that's out of whack. Let me isolate. There we go. Let's just look at this stuff. See if that's going to come up. There we go. So now when I look at this, I see that I've got some of these things are drawn at elevation, but it's not exactly the right elevation. I can see that better if I'm going to give that a 5-time vertical exaggeration. And now you can see how the things are you've got some of the 3D edges don't line up, because we're trying to make that 2D arc at one elevation. Here's another one at another elevation. Here's another one at another elevation. So what we're going to learn to do is to set those things in 3D so that they follow their proper elevation. And then we can use those as break lines in our surface modeling. In our chain link fence, for instance, we probably don't need to worry about setting those as elevations because you're not necessarily getting the ground elevation at every point along the fence. If the points that you shot were, the ground along the fence, you could turn those into it. But, we'll figure out some ways to get that data. Here's your meter wall. You see there's drops down to 0, looks like. So we'll see how, and particularly how field to finish is going to help us do that. Here's that concrete pad over here. For instance, you see the tank is sitting at one given elevation, but it's got, some different, you see how it sits above these points on the ground. So the tank is really, sticking up in the air. Now I'm exaggerated here. I'm at a 5-time. So it's not terribly high, but you see it is above these points. And if those points were along that tank corner, you want that corner to be down where that point is so that it can accurately model that elevation for you. And then everything that we're going to use to draw it, if we're using point or pattern line styles, for instance, we'll keep those as 2D lines, but we'll also create the 3D lines that help define all of these features, if they're important. If it doesn't matter for us, there's no need to worry about doing that. But you could, if you had surveyed these edges, you could exactly go through and do that. In fact, let me ask whoever's put this file together, how did this, say this line, that defines the actual running surface, how did that get created? Like, I don't see any points that were surveyed along here unless, maybe you drew it over top of a photograph. I don't know where it came from.
He's saying it was observed.
You say this was actually surveyed, you surveyed these points along the edges?
Yeah.
Yeah, with the GPS rover.
Okay, so, but we don't have any, like none of these brown points. I see a couple of them, like this one.
Those points were not added, right? It was just, these are just the elevations on it. That of the arc was probably drawn and wasn't. Yeah, the arcs are drawn. Yeah, it was drawn, but it wasn't added to it.
Okay, so whoever drew this edges in, where did that information come as to where that goes? You say that was surveyed?
Yeah.
Points were picked along. Yeah.
Okay, but we don't have those points in our data right now. I'm saying,
Yeah, we don't have the points.
yeah, so if we had other points that defined that, we can use that to actually get those elevations because they were surveyed and recorded. We can use that to create them where they're supposed to be on the ground. Okay,
Okay.
so anyway, that's the basis of how you would do that. And this idea down here of connecting up these similar points to define an actual edge so that it can form the contours across it accordingly. Those are all techniques that we'd use. We'd also take these outlines of the building and make them exclusion areas. And, if you had other things like maybe a pond that you didn't know what's underneath the water surface, you could do something like that. But like, for instance, up here, if we wanted these contours that, comes up to the edge and then crosses, flat and then comes out, so that we would see that feature better defined in the contours, we need those edges to be in their actual 3D location. And right now they're not. They're partially done as 2Ds because they're done as lines and arcs. And here's a line, for instance, that starts at 713 and ends at 6856. And that may be correct, but when we see those things in our 3D, we see that,
Make this. Hello?
yeah, so you see how there's discontinuities there?
Yeah.
It's still points.
Yeah.
Yes.
I was thinking because of time, it seems we're now going to have past noon.
Yes. Okay. Yeah, we're going to stop for lunch here. So,
Yeah.
yeah. So anyway, but those are the kind of things that we want to take a look at. So we'll talk about that when we get into our field to finish section here coming up after lunch. All right. So I'm going to turn this back
We are
on.
praying for you that the storm will not come to your side.
Wait, say that again.
The storm.
Oh yeah, we're past through the storm here. We're in good shape now.
Okay, that's good.
So yeah. So, all righty. So I'll see everybody back here at 1:30. I'll go ahead and pause that recording, put recording back on, and we'll pick back up now. So I wanted to, let's see, we did a little bit of the coordinate geometry our first day. We can take a look. Let me go back over some of these topics and let me ask you what you'd like to sort of take a look at. First of all, how are you understanding wise about bringing your data in from your data collectors? Are you good with that? Or you want to see how that's done or?
I think that one, you should just demonstrate that because they use different Trimble controllers.
Okay.
So it's good for them to see maybe how they can input the data directly to Carlson from
Yeah,
the controller.
so you have basically Trimble points that you're bringing in into these. So again, what you do is you're going to set a coordinate file that's going to get associated with this drawing file. And you can change those at any point. Like if you notice the coordinate file we have right now are just these spot heights. That's all that we have in our coordinate file. And in fact, these points up here in the north part of the project weren't even in that file. Now I've since added them over the break. I went through and I picked up all of these like these SH points. And so if you look at the point number column, as we come down, you're going to start to see there's points that were named CC tank 1, 2, 3, 4 through 9. And I've got these SH designations. Not sure what that means.
It means spot height.
All right, okay, so it was a spot height. So that's and that's done in the point number field, and the description says G for ground, which is fine. But in this case, this particular coordinate file, the only thing in this coordinate file are those points out here on the ground. I don't have any of the other survey points that might have surveyed the fence lines, the buildings and all of that, which I could, load that in and unload this coordinate file, load the other one in and keep these points in the drawing, but then have those other points show up and let me work with those as well. And so we would bring those in once we set a coordinate file. And right now, my coordinate file, if I look up here at the top green stripe, I see it's got a coordinate file called spot heights. So if I go to my points menu and I set my coordinate file, and let's call these ones, it'll be a new file, and I might call these plan features or something. Okay, so it's now the current coordinate file. I list my points. I see that I have 0 points. Okay, so to get points into that file, then I would need to import a text or ASCII file, and that's what we did with the CSV. So you could do that in that particular fashion. There's sometimes you'll see a TXT, sometimes it'll be an NEZ for north elevation and or northern eastern elevation. So a number of different extensions. You see up there in the top stripe of this, you can have an extension of TXT, ASC, DAT, CSV, all of those different things, or I can hit the browse button and choose down here these particular file types. So that's a way of bringing them in if you have those points available in a text format. Okay, now the other options would be if you bring these in, see, I may need to go to, oh, I'm in the points cloud module. Let me switch back to survey. So if I bring these in from my data collector, I would go to survey data collector. Now this is not done directly with the data collector all that often anymore because usually it's trivial to get a data file out of the data collector onto the computer somewhere. That's what we typically would just do it that direction. So, and here's where you can bring in, let's see, there's from Carlson Search CE, from Sokia, TDS, Geodometer, et cetera, et cetera. There's TopCon, and I don't see anything there for Trimble directly. And if let me see, if I look at some of these utilities, for instance, if I import coordinate points into the file, and it's going to, again, no, that's going from an existing coordinate points. Let me see. Not a particular one for Trimble, but if let's see if I do it from this one is, yeah, still the ASCII file. So I don't have any particular way of bringing these points directly in from Trimble format, but on the Trimble data collector, if they convert that to a CSV or a TXT file, then we would do that through this import text and ASCII file. Now, the other way of bringing the Trimble data in would be in this edit process raw data. And so if I choose this, this is going to be not the coordinates, but the actual observations themselves. And at that point, I can bring this in and I can import Trimble. And it's looking for a .dc file or a .jxl file. Okay, and again, I don't have any of those data sets to illustrate that, but what that would be something like this. I'm going to go ahead and open a file, and I'm going to choose this one. It's in a raw file format, but I want to show you the form that it's going to take. So when that comes in, give it a minute here. You can see I have not just the points, but I've got everything that was stored in the data collector. And here's where they stored point number 1 and point number 2. And then I've got, these description records. I've got a backsite record. I've got an HI. I did a side shot here to set number 2. I've got one to set 201 because I'm still sitting at 1 looking at the previous backsite record. So this is all the actual data. And I'm going to turn off those descriptions for a minute so that we can compress that a little bit. I'm going to hide description records. So now I've got a backsite record here. I'm sitting on 2, backsiting 1. I've got an HI of 5, a rod height of 5. So sitting at 2, shooting point 3, sitting at 2, shooting point 278, 279, 280. And if we're looking at it down here in our data set, this is a huge network. Let me close this up a little bit here. These are all being recorded as side shots and setting up a backsite. There's no real traversing being done with this. These are just occupied and setting points. So if I sit at this point, say 389, then it would come down here in my graphics that I can see. Get it to respond a little bit better here. It's still up here. Turn off. Side shots. Let's look at these. particular point. So if I'm sitting here, if I look at this observation, let me get the this point here. And so if I look at this observation that's set point number 7, it jumps to that point up here in my data record. If I look at this one here, for instance, that's set point 25, it'll jump to that point in the data record. And you see what it's recording is not the coordinate value, but it's recording the angle right of 189 degrees, 27 minutes, 30 seconds, a slope distance and a zenith angle and the description. So that's the actual observation, and that comes in through that data collector file, not the coordinate file, but the actual raw data. So that's one way you can bring those in straight from your Trimble file, either a DC file or a JXL file that comes out of your Trimble Business Center. Okay. But usually what happens most often is that when, a lot of that stuff is pre-processed on the data collector, it's actually generating the coordinates on the data collector itself. And then you're going to go to the data collector, you're going to export those points into a text or an ASCII format, either a CSV, which is like what the points that we brought in before, these out here in the drawing. And then we can just import that in straight into our coordinate file. If somebody is using Carlson's field collection software, the ServCE or ServPC, then it's going to actually generate a Carlson coordinate file, a .crd file, and you don't even have to translate it. You can just open that file directly. And then that'll give us that data. Okay, does that help that understanding a little bit? When we, again, you can set your points and you can set it to any coordinate file and then bring those in to process just pieces of it at a time if you want. Just keep track of which file is active and which points are in it so that you're not, overwriting anything that you've already gotten stored somewhere else. Okay. So let's, I'm going to close this drawing and let's open up a file here now that we're going to look at some field to finish work and what we can do with those points that are going to come into our drawing. So if we go to a file, I'm going to open up this F2F complete just to show you what this is going to look like. So here is a drawing. I'll go back to my model tab. So here's a drawing. You see it's got contours, it's got buildings, it's got line work, a fence up here in the top corner, concrete monuments, tree symbols, and that sort of stuff. It's a pretty small site, but it's somewhat like what you saw before. It's got a little driveway, concrete driveway paved here. It's got a roadway out here with the asphalt road. And you can see how the contours actually go across that curb structure and cross the road, as part of all of this stuff that we did. And the only thing that we did to do all that stuff was just measure, observe the points, and then we used field to finish to generate this completed drawing. Okay, so let's go through that process now. So I'm going to go back and start a new drawing. And I'll just, I'll use just the standard Carlson drawing template. and it's going to come in here and it's going to ask me for a new drawing name. I'm going to hit the set button. And I'm going to make sure that I point to my survey class data sets. And I'm going to call this F to F example. So that's my new drawing. I'm going to make that a 20 scale drawing. So 1 inch equals 20 feet. And I don't have any projection. I'll just say next. And it's going to come up and now ask me to choose a coordinate file, either an existing file or a new one. So I'm going to make a new file. And I'll choose this. I'll go ahead and accept this suggestion that they give me. It's the same name as the drawing file. Doesn't have to be, but I'll just go ahead and take that. And now I can import points from these various sources. I'm not going to import any right now. I'm just going to leave it at none and say next. So it finishes up. I'm now in my new drawing. There's nothing in it except a few layers have been predefined. Not very many, just a few there. And so it's just going to build on what we have set here so far. Now, a couple of things that I do want to go back and double check. I'm going to go back to my settings, to my drawing setup. And I verify that that is put it as 20 scale, but I'm going to change this line type scale right here to 1. Because the Carlson scaling computes it and sets it to match the scaling. And it really should be set to 1 so we can use some of the built-in line styles. So I'll set that to 1 and say okay. And a couple of other things that we might want to set is this view res, view, VIEWRES. That's a system variable. And I'm going to change it from its default of 100 up to 20,000. And what that will do is make sure that all my circles look smooth and circular. And it don't get those stop sign looking circles and have to do a regen all the time. So I've set that up. I've got one more I want to set. Line gen, that means turn on my line type generation for new lines. I'll make sure it is on. It is on in my drawing template, so that's acceptable. And then one last one is MSLT scale. For model space line type scale, I want to verify that that is also on, so that it can respond to show me my patterned lines when I use patterned lines. So now, what would be our process? We need to get some points into our drawing, get some things to help us to make the drawing. So I'm going to go to my points menu, and I'm going to import a text or ASCII file. And when that comes up, I'm going to choose select files. And I'm going to find this one in my data set called plat.txt. And I see a little preview of it over here on the side. That's the one I want. So I'm going to say open. I'm going to set my format to be P, comma, Y, comma, X, comma, Z, comma, D. That's very common. And over here's what they mean: point name, northing, easting, elevation, and description. They are comma separated. I can see that in my little data preview. I'm not going to add anything to the point numbers. I'm going to take all descriptions. I don't have any header lines. That would be like a line of explanatory text. In my file, I don't have any, so I'll leave that to 0. I will take all points. And now for draw points, I'm going to go ahead and tell it to draw locate points. And you can, as part of this import, you can go ahead and give it a point group. So we're just going to say, these are all coming into a group called imported. Store to the coordinate file, the current coordinate file. That's all well and good. And I'm going to say, okay. And it tells me, hey, I've read 54 points into that file. I'll say, okay. And there they are, they're drawn for me. Now that is going to be ultimately what we saw here. I'll go ahead and just leave this one open. So that's going to generate this overhead power, the power pole, the spot elevations, the contours, the buildings, the trees, the iron pins, the driveway, and all of that. So if I go back to my drawing, you can see down here the shape of my driveway. Now, what you might have to do if we're not using field to finish, for instance, we'd say, well, I see all these points that say PV, so I need to start drawing my PV. That's my pavement points. So I would say, let's draw a 2D polyline. If I'm doing it in 2D, let's instead do a 3D. Let's draw a 3D polyline. We will uncheck prompt for elevation. I'm going to set my color to be by layer. And I'll put this on a layer called 3D break line. And I'll say, okay. And now I want to start drawing points. Well, I look down here and I can see if I start at point 27 to 28 to 29 to 30 to 31, 32, 33, 34, 5, 6, 7, 8, 9, all the way around to 44, that makes that little driveway edge. So I might be tempted to just say 27-44 and hit enter. And there it is. It's drawn all the way around through all those points. And now to close it back on that original point, I could just snap to it, or I could come down here and choose close from my options. So, excuse me. So, oh, I'm so sorry. Excuse me about that. All right. So what I did here was I had all these points that I surveyed in the field on this PV description, which is my paved driveway. So I've drawn that figure in. I go up here to the top and I see these points 5, 6, and 7 make a shed. And so maybe if I want to draw that one, I'll do that as well. I'm going to draw another 3D, keep it on the same. I'm going to say 5 to 7. Now I don't have the back corner, so I can maybe fix that later, just by offsetting that, or I've got a command on the survey menu that says four-sided building. And I can just choose that and it will go ahead and complete it for me. Now, because that was 3D, you can't really tell because it's so close to the same elevation, but basically it took that 505, 530 to 505, 110, 505, 530 to 505, 820, and then it computed this back corner based on those previous slopes until it just intersected there and came up with a common elevation for that. Now let's see, I've got a straight point down here. There we go. So this would be the typical workflow that you would do. You would go through and you'd find all these points and you start collecting up points, iron pins to iron pins, utility poles to utility poles. And you'd have to sort of know, how these things were drawn to generate the line work that's going to go for that. Now, if I wanted this driveway to be a dashed line, remember a 3D line, and I made that 3D so that I can use it to model my surface, but I also want to make that as a 2D line. I'm going to change that 3D break line color so we can see it when they're generated there. So I can also draw a 2D polyline, and I would just say draw 2D polyline. And this time I'm going to put this on a layer called drive way. And I'll set my color to be by layer. And I may need to change that. Now notice I don't have a layer called driveway yet in my drawing, but just by typing it here, it's going to create it for me. Okay. I'm going to set the elevations at 0 right up here in the top. And that's all I need. I'll say okay. And I'm going to do the very same thing I did before, 27-44, and then C to close. Now let's go to that layered driveway. Here it is. And let's change
Hello,
that.
Ken.
Yes.
Please, when you are joining the lines, apart from using the numbers, is there any other way? Because sometimes practically when you get to the field, you might not necessarily pick all a particular feature at the same time. Maybe you pick one end, but then you will just pick another feature. So if you
Right.
follow the lines throughout, you might not be able to
Yes.
do what you are doing.
Yes, exactly right. So instead of being able to type that 27-44, maybe it's 27 and it's 126 and then it's 14 and all of that. So yes, you can go one by one along those. So if I'm going to erase last. So I take that 2D line off of there. And I'm going to draw a 2D line, 2D polyline. Same thing, but instead of typing in those numbers, I could type them in one by one. I could say 27, and it needs to connect. Let's say it goes to 40, and then 40 goes to 42. See, I can do it like that, or I'll just undo these things here too as well. I can also point to these points that I want to connect to. Now, notice when I point to the elevation of this point number 28, how it highlights the point location itself, and it pops up that little box that tells me that's point 28, northing easting elevation, and the coordinate file that it's in. So the reason I'm doing that is so I don't have to try to snap to the insert of those points or snap to the nodes of those points. You can do that. That's no problem. But if you want to do it with this snapping that is not always on, but that's on the settings menu, it's what we call point object snap, on and off. So you toggle that on and off. And so if it's off, and if I point to this over here to the elevation and I click it, you see it goes right where I click. Okay. But if I have it on, settings, point object on, and now if I hover on the elevation, it knows to go to where the point is. So I don't have to try to find that actual point. I know that's the point, maybe 28 or the description. So I can click there, I can click down here, I can click over to say a point here, and you see how it's going straight to those points. So you can do that any of those means that you want. You can tell it to go point to point to point. Let's say this 29 wasn't there or it was something else and I had to go to 30, then to 31, then say to 33. So you see what I'm doing is I'm just picking as I need to pick. Okay. So those are all acceptable means of creating that line. I just did the 27-44 because they were all done in order here. It was convenient. Okay. I didn't have to. I can also do it, I can mix and match. I can go say point 27 through 32. And then I can start, say go to 35 to 36. Maybe it jumps over to 40 to 49. And then maybe even I've got points out here that are just random points. Okay, so any of those ways, because what it's asking me for when I'm drawing this is, look at the prompt down below. It says pick a point, or, which means just pick a point on the screen, whether empty space or snapping to something, or point numbers. And that's the reason we like to use the draw commands from the Carlson draw menu to draw a 2D polyline. Otherwise, if I just draw a standard polyline, it now says start of the polyline. Well, I have to, snap to that point, and now my next point. But see, I can't type in point numbers there. So that greatly diminishes that efficiency if I do happen to have point numbers in order that I can take advantage of. Now, here's something else you may notice. As I've drawn these figures around here through these points, I just went point to point to point. But look at the description of point number 28. It says it is a pavement point, a PV point, but it also has a code that says PC. That's the start of a curve. Then I've got another point over here until I get around to here. It will take 3 points, because I've said start a curve, then it's going to take the next 2 points and it would make a smooth arc out of that so that it looks like this with an arc instead of what you're looking at here with these angled points. Okay. So to do that, the manual way, I'm going to get rid of that, for instance, and just draw this 2D for now. So to do that manually, I could start with, say, point number 27 and go to point number 28. And I say, okay, I know that's a curve. So what's my, I can't just go here. It's going to give me those straight corner points. But if I look down at my options on the command line, I've got an arc as a choice. So if I choose arc, then read the point. See, it's going to, first of all, it's going to assume that I'm going to be tangent to the previous point. I don't necessarily have to be, but it could be there. And I've got a bunch of different options now. I'm going to choose a second point because I know point 29 is on that curve. So I'll choose second point. And again, I could type 29 or I could snap to that. So now it's going to force a curve starting at 28, going through 29, and it wants to know an end point or a point number. So I'll go over here to 30, and that now has finished that arc. And I can go to the next point. Now that's also a PC, so it's going to be another arc. I'll come down and choose arc. I'll choose second point, and I'll give it the end point of 33. Okay, and then I go straight across to 34. Notice it's also a PC point. So now I draw an arc, second point, up to there, to 37. Again, 3 points to make an arc. So I choose arc. Now, if I don't choose the second point, it does just ask for my endpoint. So I could go right here, and it's going to sort of bypass that point, but you can see it's really close to being exactly through that point. We don't know for sure that it is, but it probably is. And then 40 to 41, and these are all just square points, to 44, and then C to close. Okay. So that's one way we can do that. And that's one way that when you're out and when you get a bunch of points and they're just sort of randomly collected, then that's what you have to do. You bring it back in the office and you sit down and you play connect the dots. Okay. But yes.
Can the description be used instead of the points? So for example, you have the files on the screen, right? And you have the edge of the edge of the asphalt, right?
Yes.
Which
The
one
PV.
particular description. In some of other software, you can use the description, then it will join all those lines for you. Then you can do a minor editing, just like you did for the
Yeah.
points.
Yeah, exactly. If you do, you could do this. You could say draw Polyline, well, you could do, say, by nearest found, and then you want to match a description of PV and take anything else, because I've got some that say PC. And I'm going to put this on my driveway layer. Now, if I do this, I'm doing it by nearest found, and I say by screen, and it's only going to, so if I select like all of these points, it's only going to look at the PV points. But look what happened. It started here and it went to the nearest one. So 37 was closer to 30 than it was to 36. So that wasn't really, something that was helpful to me. I could have, I still need to control that order, but if they're close enough together and if they form the actual continuity by nearest neighbor, then I could do it by description, just like you said. Okay. And that's sort of nibbling around the edges of what field to finish is going to do for us. Okay. So we're going to take a look at how we can use field to finish to draw some.
You have to use the descriptors a bit different.
Did that answer the question?
And there's somebody here wants to something.
I think it can be done in using the descriptor, but you got to code it a bit different. Based on the sketch that you have, the point you have in the drawing now, that's why it won't work like that. If all the PVs were, say for instance, PV1, PV2, PV3, I think the software should link it in that order.
Yeah, well, it can, but when you put a number suffix on that description, like PV1, PV2, PV3,
Right.
in field to finish, what happens is it takes that PV and
So it will
connects.
have all the PV1s in them. So all the points that are for the driving on the left side of the driveway, for example, would be PV1s in that sequential order.
Yeah,
So when
you're
it goes
saying,
there,
yeah, I know what you're talking about. Like if I go to my points, if I go to say, I'm going to edit these points and let's go to 27. This is what you're talking about. You're saying here, I want to call this one PV1. This one I'm going to call PV2. This one I'm going to call PV3. And so it doesn't matter on the point numbering over here. It's just going to read that and take that as the next ordered point. That's what you're getting at, right?
I think in some cases you can have the same code, so they'll be all PV1s. So there's PV1s on the left side of the driveway and
Yeah.
PV2 on the right side of the driveway.
Right. So you could have, if this, say 27 down to 33, if those
Right.
are PV1s,
Right.
and then from 34 up to say 43 or 44 was PV2.
Right.
Okay. So yeah, you could do that, but then you still need to say, I mean, well, let's just, we'll run through that real quick. Let's edit these points and let's go down to 27. We're going to go to 33 and we'll call this one PV1, either with or without a space here. So these are all, whoops, PV1s. All right, so there's that. And now for PV, for the left edge, I'm going to call that one PV2.
No, but that means you spend more time in the office.
One side.
Rather than in the office. Oh, you know.
That's why most places work to improve, most places don't run the system. Yeah.
Okay, so I'm gonna I'll save those. And now we've got PV1, 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 and then PV2, PV2 all the way around. So then we could do that same thing where we did before. We draw a polyline by nearest found. And we'll take it just the PV1s. And even if I select all of these, that connected all the PV1s. I repeat that command. And this time I'm going to look at all the PV2s. Actually, I should have done that, because I missed those curve points. But so that took all the PV2s together, and that kept it from jumping across. Let me redo that one, and we'll make that PV1. That way we'll get them all. So yeah, see that let me choose that as well to do it in that regard. Now, it still just happened to work out that the order and the point that was next in line as far as being nearest just coincidentally managed to work. But if we have the reason we use these PV1s and PV2s when we are using field to finish is, for instance, if you're doing a road and you've got a edge of pavement point, an EOP, and you start a bunch of EOPs over here and you're back and forth across the road. Well, the ones on one side you'll call EOP1, the ones on the other side you call EOP2, and it starts drawing those points. And if it sees the one, it knows, even though they're all EOP points, it knows the one, all of those points get connected together, and then all the twos get connected together on its own separate feature. But it still has to rely on the order that the points were actually surveyed in as well. Okay, so I'm going to go back to, I'm going to reset that point file. And I think that will work. I'm going to overwrite all. Oh, it's doing duplicate points. Let me get rid of those and do it one more time. There we go. Let's see. Yeah, now we're back to those PVs. All right, so and we'll talk about that when we get into the actual field to finish. You'll see how that suffixing works when we do that. But the point is, we've got some controls, this extra little description here of saying that starts a curve and it takes the next 2 points to make the curve. We could have, and it's my preference, that instead of calling that, instead of just relying on it being the next 2 points, I'm going to explicitly say that's the end of the curve with a PT designation. That's the way I prefer to do those. But if you don't have the PT on there, it just defaults to taking 3 points to make the curve, and then it goes back to the lines until it hits another PC. All right, so again, as we're doing this, we're trying to bring this in and create that drawing, just like you saw in the one where it had all the building outlines and that track oval. Those are produced by these points that we survey along the edges of those features. Okay, so we need a way with that is going to help us to draw those things together. And if I look at, I'm trying to see if I've got some things like up here, I've got, those are my shed points. I've got a point up here that is a fence line point. It's also a concrete monument. Down here's a fence line. And then I've got an iron pin here. Down here, I've got my edge of pavement. That's 45's edge of pavement. And I come up here and I've got another edge of pavement, starts a curve, another edge of pavement, edge of pavement. So these are not necessarily drawn in order. Yeah, because here's 47's an edge of pavement, 48's a hub, but 49's the edge of pavement. Okay, so I could do it like this. And I'm going to call that edge of pavement. And I could say start down here at this 45. And I go up to 46. Now that's an arc. I'll say arc. Second point, I'll get that one. Now I'm skipping 48. See, and I'm going to 49. And then, oh, there's one that's a PT that actually should have been another arc come along there. We'll fix that a little bit later. And then I come all the way up here and there's another edge of pavement here. Okay, now, if I'm doing these points in order, so there's 45, went to 46 to 47, but 48's a hub, 49's a pavement, 50's a pavement. Yeah. Well, it doesn't have to be 51, it just has to be greater than 50. Then over here's a 53 is a manhole, there's a 52. So they did all those in order, but they don't have to be, they just have to be drawn in the order as if you were drawing them in the field. And that's the mindset that you need to use out in the field, or that the surveyors need to know, is that as they're collecting these features, they need to get them in sequential order that defines the feature, as if they're drawing that on the ground out there when they're surveying it. So don't jump down here and grab this point, jump over, grab this point, jump over here, grab that point, jump back and grab that point. We need to have a little bit of sequence there that defines that feature. But you can intermingle all of these PV points with other things, iron pins, manholes, power poles, trees. You can interrupt what you're doing with those other features, as long as all of the ones that say PV or EP or whatever you're doing, as long as they are done in order that it's going to be drawn. Okay. So instead of having to come in and play connect the dots with all of this, what we're going to do is use field to finish to have it draw some things for us. So let's take a look at that process. If I go to my survey menu and choose draw field to finish, when this comes up, it's going to ask me, I've got a range of points. I'm just going to take them all. I'm going to draw not only the points, but any line work and symbols that I tell it to draw. And I'm going to look at this additional draw options button. So if I choose that, it lets me do things like use point numbers and descriptions and notes and elevations, etc. Locate the points on the real Z axis, locate line work at elevation. So in other words, those building footprints can be in 3D by code. And then the PCPT curve type, right there, this sequential arcs, that's the one that says go to 3 points and make an arc. If I were to say best fit, then it takes all of the points that are defined along the curve and it fits a circular arc through all of those points. So as you can imagine, they're not going to all lie exactly on that circle, but it would be a least squares best fit. Okay, the other one is a Bezier curve, which is sort of a smooth curve through all the points and it will go through the points, but it makes the radius of the curve arc that goes between any given successive points, they're going to vary slightly. That's more of a, like if you're, collecting, say, some like a sinusoidal sidewalk or something along those lines. Okay, so, but right now by default, let's leave it at sequential arcs, and then we can create point groups based on the codes and the definitions and all that kind of stuff. We can allow 3D arcs, which all that means is that if it draws a circular arc, it can have a non-zero elevation, but it still is planar. It's still at one elevation. All right, so that's really all that we need to look at on the additional draw options. We're going to erase any existing field to finish and erase in range up here at the points. So as we fine tune this stuff and redraw, we're going to tell it to go back and erase the other stuff and redraw it for us after we've made corrections. So now the two things that we need to look at below are a code table, an FLD, that's our field codes, and the coordinate file that we're using. So right now it's our current coordinate file. So our code table, I'm going to hit the set button, and I'm going to look in my Carlson Projects settings folder. That's where it's going to look first. If I look in my, see if this is the one I want. Let me open this up just a minute and I'll get right back to you. I'm in ground features. Yeah, okay. So let's go back here for this code table. I'm going to choose the set button, and I'm going to look in my, I have to pull this down from settings and choose my data set that we've got. And I'm going to choose this F2F example.fld. And I'm going to open that up by choosing the open button. It's now set to be the code table I'm going to use. I'm now going to edit the codes so you can get a sense of what's going to happen here. And I look over here on the left-hand side, and I've got some features or some categories, and these are just ones that I've created or the code table has created. I've got some that aren't assigned, and I've got all of these points. Now, there's a couple of things that you notice. Remember the points that we were drawing down here called PV? If I look in my list, I don't see any PV points. I've got EP points, edge of pavement points, but I don't see the PVs. Okay, so that would be, if I were to just say, exit from my edit and say, okay, and let it draw, you're going to see some things draw. Like the edge of pavement drew, the fence line drew, this traverse legs drew, and these building edges drew. But my driveway didn't draw because I don't have that code defined in my code table. So I need to make that code happen in my code table. And here you can see this one on the edge of pavement. It hit that edge of pavement point. If I double click that point, I see it had an EPPC as its description. So it started the curve there. It went here, and it went on around because this one is where it said PT. It ended the curve. So I've actually got 2 points on the curve. So it went from here to here to here and did an arc, and then it finished the arc out to that point there. So you can have more than 1 point along the curve. You have as many as you want. So what we've drawn so far is what our code table said to draw. We notice we don't have PVs, so we could add that code and do it again. So I'm going to go back and repeat field to finish. And when this comes up, I choose edit codes. And now I could just add that in there, but I've got some controls down here where I can report these codes. Or if I go back out a level and choose report codes and points, I could say report any data points, and I've checked to only report undefined point codes. And I'll say, okay, and I look at this and I see, all right, here's all my points. And it says I've got 35 points that have undefined codes. And look at the ones it found. UP, IP, 18D, 24D, 12P, 8P, all of that. There's all my PV points. And I've got MH points. Those are my manholes. So I need to add those descriptions into my code table. And I can do that with a button. I'll go to my edit codes. I'll click that. And I'm going to say code table by points. If I choose that, it says, okay, do we want to append the current table or create a new one? Well, I'm going to append this table. I have a default point symbol, and it says to remove any appended digits. So if I had PV1, PV2, it's going to remove those digits, not from the point, but from the code that it creates. So I'm going to append my table, and now I see that I've got some points in here that have been added. And unfortunately, they all went into this trees category instead of unassigned. So I need to come down here and choose these ones that we've added. So I'm in trees. I've got tree, oak, pine. That's good, but I've got a utility pole, an iron pin, these 18, 24, and 12, D and P, those are trees. 8P is a tree. And there's a, oops. These two, PL and LP is a light pole. There's my pavement and there's my manhole. And I'm now going to put them into a different category. So I'm going to come down here and say move category. And I'm going to move them to right now to be unassigned. Except I didn't do that. I wanted to select each of those. Let's see. I may have to do that one at a time. Let's see. Tree, oak, pine, 18 to use 8P, PL. If I move that to unassigned, there we go. Now, these are the codes that it found in my set of points that were not in that table. So now I've added those two there, and I just have to tell it what to do with each of these points. So let's look at the first one there, the manhole. Let's choose the edit button, and let's see what it's going to tell us that it's going to do. Right now, the code itself, the actual description in the coordinate file says MH. This description is a description that will draw in the drawing with that point. I could spell out the word manhole, or I could type SAN manhole for sanitary manhole, anything I wanted to do, and I could put that on a particular layer, and I'm going to put that on a layer called, let's put it on sand sewer. We'll put that on that layer. And I'm going to look down here at the bottom and see what I want to do. I can either just draw points only. I could draw 2D polyline, a 3D polyline, or both 3D and 2D. But for my manholes, let's just do points only. And let's go to the symbol tab now, and let's choose a manhole symbol. So I'm going to choose that, choose my inlets and manholes. And I'm going to scroll down here and find a sanitary manhole symbol. And you can give it a size. Let's make those say 0.15 inches tall. We'll say okay. So now, oh, one other thing, if I edit that code again, instead of this category unassigned, I'm going to put it in utilities. Now it's no longer there, but it's here. There's my manhole. Okay. So let's do the utility pole. We'll edit that. And we're going to have it just type pole. I'm going to put this also on my layer utility, which I don't have yet, haven't run it yet. So I will put that on utility or just UTIL. And I'm going to go to my symbol and I'm going to give that a point. I'm going to choose the category up here for points. And I'm going to scroll down till I find what looks like a utility pole, maybe this one. And in addition, I'm going to draw a line between all those utility poles to represent, the overhead power lines. So right now I'll leave that line type just to be by layer so I can define it in my layer list, and we'll leave it at that. Go back to general, and I'm going to draw not only the points, but I'm going to draw that as a 2D polyline. So I will get the point as well as the 2D polyline, and I'll say okay. And again, I'm going to go back and change it to utilities. I'll make sure my manhole was on sand sewer. There we go. All right, so next I've got an IP. If I edit that, I'm going to change the category now before I forget it. And that's going to go on, I don't have the one I'm looking for. So I could call that one, let's put it on set control for the moment. We'll change that in a minute. And this is going to be an iron pin. So I might spell it out or put IPF or iron pin found, whatever we want to call it. I'm going to put it on a layer. If I've got one here, I don't see. There's a monument layer. Let's put it on that layer. And I'm going to put points only for now, but we could say draw them with a 2D polyline. So that would be the property line itself. So I'll choose that symbol is okay for the one I want. My line type, again, by layer, or I could give it a specific line type. And if I choose them, I want to find a property line. Entity. I want to get out of the entities sections. CAD, line, slope, I'm going to P. There's a property line right there. And actually, let me then set the line spacing is how many inches between symbols in my plotted line. So I'm going to make that go just every inch and a quarter. And I'll make my text to be 1/10 of an inch tall. And that should work. Now, this is when we're talking about that PV, I'll show you this again, but down here in this line type tab is where you can choose either sequential or nearest found. And we most often do the sequential. order. Okay, so we'll say okay to that. And I've got a PL, which was a, I think that was a point on line. And so we'll just make that a PT on line. And that's also going to go on that monuments layer. But we'll do points only, and I'm going to change that point to be an X. Oh, I need to make another category over here. So I'm going to make a new category called monumentation. And so now my PL is going to go on monumentation. And so is my IP, which wound up being set control. I'm going to put that actually on monumentation. Okay, so we're getting close. LP is a light pole. And instead of creating the line to connect those, I'm just going to put a symbol. And again, I'll scroll down here and find something that looks like a light pole here. And I'll leave that at a 1/10. And I'll make sure that it's points only. And that's also going to be on utilities. And let's put that on a layer UTIL. And now finally, the ones that we've been working on, this PV, that's my pavement. So if I edit that, I'm going to put its category on road features just because it's a paving. And I'm going to, for this description, I'm going to take the description out. I don't want it to draw the description. I just want it to generate the line work for me. And I'm going to go to my symbol and I'm going to choose this blank symbol. So it's not going to draw the actual symbol for me. And I wanted to draw 3D and 2D polylines. And I'll show you what that effect will have here. So we're going to put this on our driveway layer. That's going to be where that 2D polyline goes on. But the 3D, the dual 3D layer, I'm going to put on this 3D brake line. Okay. So now it's going to read the description PV. It's going to not put a description in the drawing and not draw a point, but it's going to draw lines 2D and 3D, one on driveway, and then the 3D on 3D brake lines. Say okay to that, and now everything's good to go there. And if we save our code table and then choose exit and okay, you're going to see the difference now. Now we have the pavement, which always drawn all around, and you can see the points are still there, point numbers and elevations are there, but the descriptions are not there. And you can see the curves. Now, if I zoom in tight here, you can see that this is that 3D polyline, and it's drawn by a sequence of little line segments. But this green line is an arc. You see it as a start point here and an end point here, and that's the middle point of that circular arc. Okay, now I have to do that if I want to be able to see those dashes as part of my finished line work. That's why I draw that as a 2D, so I get the feature drawn down at 2D just for my mapping, but I've got this 3D for modeling the edges. Now I've got a couple of things here. I've got these poles. This was my UP code, and my UP code said to draw this line based on a line type of by layer. So that's my layer utility. So I could make that everything that draws on layer utility would use that line type if I kept that code there. So I may make that a specific line type here in just a minute. Up here, I've got my fence, and I can see that fence. Look how tight the spacing is on there. So I need to resolve that spacing a little better. I've got my edge of pavement, which just drew the 3D. I probably would want that to be a 2D. And I see that I've got my property line is drawn, wow, with a real tight line symbol there as well. There's my sanitary manhole. And again, they're just manholes. I didn't connect the lines. We could have done so if we knew that they connected, but we don't know that. So let's go back and resolve a couple of things here. And one of the things that I can see is this point number 44, the last point of this driveway feature. It just says PV, but I have a special code called CLO that says close that point. And so now the next time I draw this, it's going to read that CLO and it's going to close that figure for us. So let's go back to field to finish and look at, I'm going to edit the codes, and I'm going to look at that PV. And because I know close is going to close it, I've got something else that I can do with this on the line type business is to, if I, let me see. Yeah, right down here. If I choose to hatch the closed areas. So it's going to close, and it's going to be a closed area. And I'm going to select a hatch. I'm going to just find this concrete, which should be, choose this one here. And let's see if I can set that scaling. The hatch scale is 10. Let's put it to 1. Let's see what that does. We may have to adjust it. All right, so that's going to be there. Now, one other thing we didn't talk about is this full name field. I'm going to just say that is pavement driveways. And what I'm doing with that is, you see how that shows up in this category here? All that is just a label to tell me what it is. That doesn't do anything to the drawing. All right, so we've done that. We need to take the utility pole, which was this one, utility pole. And its line type, instead of going by layer, I'm going to make that a specific. So that's an electric line. Let's say here, I'm going to set that to be 1.25. And that's fine there. We'll say that. So 1.25. That should work there for that now. And the iron pen, also I needed to up that line style here. If I change that, I guess I have to do it. property line there, 1 1/4, 10, there we go. So let's see if that will now fix that. Save that, exit and choose OK. So there now it drew my pattern in. I still see my line styles are just still too tiny. I've got to fix that here in a minute. I think I know why. Look at my drawing setup. There's my line styles 1. That's okay. Is MSLT scale is on. Okay. Let's go back to my field to finish. We're going to set that pavement scaling 10. So that should fix that. Now my edge of pavement, I may also want 2D and 3D. I'll set that on 3D break line. I think it's there, and I want to set the fence line type see the fence B and C. CC fence BC, this one. I want to set that to be 1 1/4 inch, 1/10. That should create that 1 1/4. See if that's fixed it. All right, so we got the scaling of the driveway corrected. This is still not set. I need that to be. It's looking like 20 scale. Scale to there. Let's see, and then we'll set that back to 1. There we go. So there's my property line, and there's my electric line. Poles, and then when I'm finished with that, now this is a traverse line between my control. These are my traverse points, my hubs. And I've got a couple of things to notice here. When I've drawn this, you see I've got 3D edges on those pavement features and up here on this shed, but I've got everything else down here is a 2D feature. So it's not, those are drawn because they're going to be just line styles, and they don't define an actual edge on the ground like this roadway does, the edge of the pavement. Okay. Now, the rest of these, some trees and this symbol right up here, this point number 1, If I look at that 0.1, I see it has a description of FL, which says, okay, it's a fence line point, but it's also a CM point, which is a concrete monument. And this is a 4-inch diameter. So points can have more than one description on them. In fact, if I were down here and if I were shooting this point in the field, this point 33, if that point was right on the edge of pavement, I might call that PV and then EP also, so that it would become an edge of pavement. Now that's going to interrupt because I've got 33 to 34 and I've got 45 to 46. So that's going to screw that up in there. So we'll let that one go for right now. But let's take a look at the shed and the building. The shed's in 3D. So I'm going to edit these codes again. Look at my buildings. There's my shed. And right now it's drawing a 3D polyline. Well, I'm going to have it draw just a 2D polyline instead. I'll leave that on that layer. It would be called shed. Just a standard little X tick if I wanted. And let's see, building, we had the same thing. It's going to type building. It's going to be building 2D polyline. So that one's good. And let's take a look now at a couple of things that field to finish is really going to help once you are starting to use that in the field and you learn what you're, how you're going to survey this information. So just like we did before up there with this shed, when we did that 4-sided building from the survey menu, field to finish can draw that for us the same way. So if we've got a 0.5, 6, and 7, if we somehow could tell that 0.7 to go ahead and finish drawing that as a shed, then let's do that. So that's going to be a special code. So I've got a special code down here in this bottom button. And I'm going to take a look at some of these special codes. Now here's a ton of special codes. This one is used quite often. This one is a / character append description. So we're going to use a slash, and that one's also in one of our points up there, that fence line and concrete monument. So that means anything following the slash in the point description is going to be written into the drawing as additional description in the drawing. I've also got over here, you've already seen this PC that starts a curve, and I've got a PT that ends a curve. Now you can make these whatever you want, but these are the ones that it's, by default set up for. Down here, CLO, that was that close point that we put on the pavement of the driveway. That last point, we put a CLO there, and that said to close the point. And notice right next to it, I've got this point that says rectangle. That means go ahead and make a rectangle. So point number 7, if I put this extra code on RECT, that's going to go ahead and fill that out as a rectangular feature. Okay, so I'm going to go to that point 7. Go over here into the right-hand set of buttons, and I'm going to choose Edit Points. I'm going to find that point 7, and I'm going to go to the end of that and type this as my description. And that should have been what I put in the field. So if I'm in the field and I survey these points, I'm going to say 0.5 is a shed, 0.6 is a shed, 0.7 is a shed, RECT. And then when I draw my field to finish, you're going to see that complete that out as a drawn rectangle. A couple of other ways to use that rectangle code. Right here's a point 18 to 19 called BLD, and they have, that's a distance. I look at the length over here, it's a 20-foot line segment. So I got 20 points here. Now, if I said rectangle, I'm shooting point 18, I shoot 19. If I say rectangle, it doesn't, I don't have that second leg, so it doesn't know how to do it. But if I do a code here instead of just building, I can say rectangle, and then I can say, let's say if I wanted to go 10 feet to the left, I would put -10, or I just put a +10 if it were to the right. And so now drawing field to finish. Now just go ahead and draw it. You see what it did is it took those 2 points. I'd said rectangle, but I needed to give it a distance and a direction. So it did that for me as well. Now, there's another set of special codes that can do more than just rectangles. Let's say I saw that point 18, I saw this point 19, but really the building corner was out here another 10 feet, but I couldn't get to it. There was a bush in the way or something. I couldn't occupy that point, or I couldn't observe that point. So I can do what are called jog codes. And if I go to that code table again, edit my codes, I'll look at my special codes. I see that I've got a code over here called jog. And that is equivalent to extend by distance. Now, what that is, I'm going to go ahead and exit all this and cancel that for a minute. I'm going to show you what that means. Is there's a command called extend by distance, and it's in our, I think, draw edit. It's under edit extend by distance. Now, when I run that command, it wants me to pick an arc. So let me or pick a segment. Let me erase these guys here. All right, so when I run the command edit extend by distance, if I choose closer to this endpoint, it puts me a little marker there and it says, all right, what do I want to do? Now look at all the choices on the command line down here. And if I type the question mark to tell me what it's going to be, actually, that's not, I wanted to type H for help. So here's how that command works. I've got all of these options. I can type a number, which means that's the distance to draw. I can rotate, I can close. If I rotate to the right, there's a right rotate, it goes 90 degrees to the right. I can do a total distance. So depending on, regardless of what that is, if I know that total distance, I can set that. So there's all of these different things, and they're just basically draw commands. So if I'm there, I'm going to say, I'm going to draw, enter or pick a distance to draw. If I say 10 feet, it's going to go out 10 more feet. Then I'm going to go left. So L, 10 feet. So I'm going to turn left and draw 10 feet. I'm going to turn right and draw 10 feet. So now I went 20, I'm 30, I'm 10, I'm 10. If I go left, let's say 15 feet this time. And I'm going to turn left again, and I've got 10 and 10 and 20. So let's say 40 feet. And then I could type, I think C to close. Yep, so that would do that. All right, so I can do all that actually right out there in the field by this fashion. If I go to point number 19, and instead of rectangle 10, I'm going to say jog 10. So it's going to go 10 feet out, go left 10 feet, go right 10 feet, go left 15 feet, go left 40 feet, and then close. Okay, now that's a big thing to have to code into the data collector. But if I'm doing this in field to finish and I want to come back and have it take care of this for me, then when I run this command now, draw field to finish, except I obviously gave it the wrong directions. Let's see. Actually, I need to put an S in there for straight. All right, now let's draw field to finish again. There we go. So it drew from our point 18 to our point 19. It went straight 10 feet, left 10 feet, right 10 feet, left 15 feet, left 40 feet, and close. So I drew that whole building just by surveying 2 points on it. Now, if I needed the elevations out there on those corners, I need to go and survey those points. Right now, it's just a 2D line and it draws the footprint for me. And that may be all I'm interested in doing. Okay. So, be aware of what it is that you're wanting to create as to whether you can use those points or those particular codes. Now, here's another option. Here's a light pole that's just out here in the yard. That's fine. Here's a power pole at point 17. It's a power pole in the yard, and the main power goes past our shed here. But let's say that had a drop over to my shed here at 0.7. So if I did this power pole or utility pole, I'm going to type another special code called JPN, means join to point number 7. And while I'm at it, I'm also going to say jog straight 30 feet. So what will happen in this case, you're going to see it draw up there and it's going to connect a line back to that point. That was my jog to point number, even though shed has nothing to do with UP. So it just took all of those UP points, drew that line, connected it over, and it also extended it out another 30 feet just to indicate that it's going on off the site. I didn't get the other power pole, but I've got that one and I'm indicating where it's going. Okay. Let's work on our double coded point up here. Point number 1, if you remember, was fence line, which drew the line of the fence, but it also says CM. That stands for concrete monument. There's that slash 4-inch DIAM in parentheses. It means everything after the slash is going to draw as extra description. So let's look at, I'm going to edit the codes. I'm going to look at my monumentation. Oh, it's a set code. I'm going to put this concrete monument. I'm going to put that in monumentation. It's a concrete monument. Right now, it doesn't draw anything. It doesn't put anything in the drawing as a description, except because it used that slash code. And it said slash parentheses 4-inch diameter. That's what it's going to draw into the drawing for me. So I'm going to go to my symbol, and instead of using a square, I'm going to use a circle. And I'm going to make it a little bigger here. I'm going to make it 0.2. And then that should set that. And we'll see that here in just a minute. Now let's take a look down here below. I've got these other 18D and all of those are trees. So I've got a code called tree, which I don't think I've got any points that have that, but I've got 18D, 24D, 12P, and 8P. So the Ds are indicating the diameter, and the P means it's a 12-inch pine and an 8-inch pine. So if I take this 18D, that's its description right now is 18D. I may take that out. I don't want to draw that. I'm going to put this on layer trees, points only. I'm going to give it a symbol. I'm going to choose trees, and it's going to be an oak. Maybe I'll use this one, and I can give it, let's say 0.18 to correspond to an 18-inch, maybe. And here's a 24-inch diameter. I'm going to do the same thing, take the description out, put it on layer tree, choose that symbol, and make it 0.24. And then my 12-inch and 8-inch pines, I'm going to say the same thing here, put it on tree. Choose pine tree. Twelve-inch pine. Same symbol, but we'll make it 0.08. Let's see if I tree. So now when they draw, you're going to see the description for our concrete monument now makes sense. It has a size and a diameter. I've got these trees. There's my oak tree. And that one is, see if I can find the scaling. It should have been different sizes. There's 1818. So you see this one is showing bigger than that one. And then my pines, there's my little pine tree, my bigger pine tree. Here's my 8-inch pine, my 12-inch pine. Now, this one says oak because that's drawn the description. See that slash oak? That means everything after the slash is going to print. And it didn't down here because all it said was 8P. So that's an 8-inch pine tree. And if I wanted that to show up, then I would put, say maybe PINE. Same thing for that. And then repeat my draw field to finish. So now it does say pine, and they're sized relative to each other. Now I may want to
Ken,
up those. Yes.
in the next few minutes, someone has a question.
Okay.
All right. I don't know where to post.
What was the question?
Hello, Ken.
Yes.
I don't know if you can take us through this. We have a template we use, and for instance, we have a particular symbol for a feature like an electric pole or a light pole, which
Okay.
I don't think it's part of the symbols
in
on
Carlson?
the Carlson, yeah.
And you want
So,
to know, yeah, and you want to know how to put that into those so you can pick them. Very excellent
yes,
question. Yeah.
if you
So,
could,
yeah, absolutely. So here's how you do that. It's a very good question. I was going to say if we had one, I think I've got some others that we can load in here to see. So let's go to the settings menu and choose symbol
so
library.
if you could go back to the drawing we sent you, I would
Oh, yeah,
guide you to the symbol and then you use that here so that we see.
perfect, perfect. Yep. So let me open that one up, which was this one. Okay, so we have,
You can check on the legend, it should be there.
all right, so we've got, this girth of tree.
Okay, we can use that one.
Use this one.
Yeah.
So that is a block here called trees PRD for tree spread, I guess. And let's also look at a couple of more of them down here. I've got this one here. So that's a lovely tree called tree 19. And that looks like that's all tree spread. Tree 19 looks like maybe, oh, here's another one here. And that's a tree 9. Now those might be part of Carlson. I don't know. There's one just says tree 5. So 5, 9, what would we say, 19? Yeah, and the tree spread. So what I'm going to do with this now is I'm going to transfer those blocks over here for just a minute. I've got that particular drawing open. I'm going to look at these blocks. And I'm going to find those blocks. I've got down here, tree 5, 9, and tree spread, and tree 19. Now those tree numbered things that I don't know, maybe that comes out of Carlson, but still you've got this other one as well. So if I have those in here as blocks and I want to put them in my drawing, so I'm going to take all of these and I'm just going to drag and drop them over here on blocks. So they're now part of my drawing. Okay, so I'm going to go now to the settings menu. Oh, and if you, let's see, you're using the standalone, the OEM version. So if you open up your drawing, let's do this. And let's do this command. I want to get these out into a separate file so that you can see how to add these in later from your collection of files. So if I type W block to write a block, I'm going to now choose my source as a block, and I'm going to find that tree spread, which is right here. And I'm going to come down to the file name and path. I'm going to choose that, and I'm going to make sure that I'm in my data set that I'm working with here. And let's see if I make a new folder inside of here. Just going to call it blocks. So tree spread into that folder. I'll save that. And I'm going to say, okay. So I've now written that out as a drawing file. I'm going to do the same thing with, say, this tree 19. We'll just do these two. It's in the same location, that name, I'll say okay. And we had tree 9 and tree 5. Oops. This is what I'm looking for, tree 5. Okay, so now I have in my blocks folder, if I go to open this, I've got there's tree 5, tree 9, tree 19, and tree spread. Okay. So they're out there on the disk waiting for me to put into my symbol library. So I'm going to go to the settings menu and choose symbol library. Okay, and I've got some categories here. And if I look at these categories now, I've got a tree. Yeah, that's a tree 5 and 9 and 19. So they're already in there. So that's okay. But we don't have tree spread. Okay, so I want to add, not a category, but I want to import a symbol. So if I import, and I'm going to go up here now to my data set and look in, whoops, I'm in the wrong. There we go. I'm looking to blocks and I'm going to find that tree spread. And I'm going to say open. And that's now going to go into my library, but I need to confirm it. Selected files here is not in the directory. Would you like to copy it there? Yes, I would. So I'll say, yes, it's now part of that category. I'll save and exit. And so now let's use for these oak symbols that category. So if I draw this, I'm going to edit my codes. And that was my trees. And that was both for 18D and 24D. I'm going to go to symbol and I'm going to, instead of trees 11, I'm going to scroll down here and find tree spread if I can find it. I blew past it. Oh, there it is, right there. And let's go ahead and make this a little, let's double this up to 0.36. And for my 24, why I keep blowing past it. There it is. And we'll double it up to 0.48. Okay. So I'll save that, exit that, and redraw these. Oh, it was a much larger symbol than I thought it was. All right. So
You made it 4.8 instead of 2.4.
yeah, so if it was, so that's not drawn at unit scale in the drawing itself. If I were to open, let's open that tree spread. And let's see how big this is. So if I measure, let's see, I measure from 0, 0 out to say here. I see that's an actual distance of 13. So it's 13 scale. So it's like it's architecturally drawn. That's fine. So I just need to know that that's the size of that, or I could rescale this down to make that 1 unit. Right now it's 13 times too big. So that part's okay. I'll just leave it there. I'm not going to change that. And I'm going to go back to my field to finish and rescale those down to where they're appropriate. So I'll use that symbol now to make this different. Let's see, 0.36 divided by 13.
Zero point zero two.
0.02 0.02 for that one. And then for this one, 0.036. 0.036. That should do it. I may still be a factor of 2 off. We'll see what it looks like. There we go.
19.6.
Okay, so that's how you add those into those symbol libraries. You know, there's a couple of things too. When you look at that symbol library, you can actually make new categories over here. You don't have to put them in these existing categories. So you can add a category and you can make, you know, all kinds of different things. Like if you've got utility symbols that you use, anything from your block library, you can add all of those in and make that part of that library. Okay. And if you have more than one to do, like right now I did this import symbols and I could, and so you can hold the control key or the shift key and you can bring in any number of these, you know, any number of little block drawings that you have out there on your disk, in your file system. Okay, so you can bring that whole library in at the time. Now, one of the things to realize is when you're doing that, the best way to have those drawings is when you, let's go back to that tree spread, is when you're making these symbols to go into the Carlson library, the best approach is to scale all this stuff so that instead of it being, you know, 13 units across to the outer edge, or in other words, 26 units all the way across, you would rescale those to where they're exactly 1 unit, top to bottom or left to right, whichever way you do it. And then that way, you know that they're drawn at what they call unit scale. And then when you type in those numbers for what size to make them, you can use them like you would put in a number that would correspond to the number of plotted inches that you want to see. But again, not entirely necessary because you can change that size in your code table. In fact, I'm going to do these pines. Up their size a little bit because they're too small. Edit to codes, trees and such. Just going to make that double, so 0.24. And my 8 will be 0.6. There we go. And now the pine trees look like they're supposed to look. And then at this point, you know, you could, you know, you freeze on and off your point numbers and elevations and leave the descriptions, if you will. You could even at this point, because we didn't come into this iron pin and say PC, but see, after you're done, you can always do something like this. You could convert that to an arc if you knew, you know, a point that went through to be there. Now that point number 15 needs to go up here to point 1. It needs to connect back to that symbol. So you could just do a joined point number up to 1. Now I could do that and redraw the whole thing over again, but I'm going to show you a little shortcut. If you're just making a couple of little changes, I'm going to go to survey. I'm going to use my field to finish inspector. And now I'm going to come down here and I'm going to find this 0.15. And I know that's a code that's called IP, so I'm going to say iron pin, and I'm going to choose 0.15, and I'm going to change that description to be JPN, join to point number 1, and that will take it back up to this concrete monument. Okay, so if I choose that and choose apply, I choose the point that I want to apply, and I'll say okay. And now that's put that in there. Now I'd have to go back and add this arc if indeed it was an arc. You know, that's a property line. So I'm taking liberties here, but you see what I'm able to do with that. And so now my property lines go accordingly. Probably the fence line is also a property line, but you know, you can do those as you will. You can freeze off, say, the traverse and the control points. And now I've got light poles. Oh, I've got some points over here that are my spot elevations. If I look at that point, it's just called X. So if I go back to my field to finish inspector, I'm going to scroll down and find that code X. And I'll take all of these points. Oh, and let's see. Let's look at the code X. I'd have to change the, I'm going to say I could put an X and then put that, yeah, let's do it that way. I can't do this without redrawing this one. If I do field to finish, I'm going to edit that spot elevation text for X spot elevations, no description. It's going to be a text attribute. But if I use the attribute block and then choose this attribute, which is going to look like that elevation off at an angle, and then I'm going to put this on distinct point. We'll say, okay, save and exit. And then when that draws, you're going to see those spot elevations are going to show up like this. And then if I want to, you know, freeze off my point numbers, freeze points, then I'm left with that as a spot elevation in my mapping. Now, if I wanted to freeze these other elevations, but leave those on, I'm going to do that right here, and you're going to see that they're all going to go away. Because if I look at that code X, and I'm going to also up that symbol size a little bigger. But back over here, because I'm telling it that I want to use an attribute block, but I say separate attribute layers, none. But if I say I want to make them I want to use these separate layers, and I'm going to say I'm going to have a spot and a spot number, spot elevation, spot description, and spot mark. Those are all going to be on these new layers by themselves. So now when they draw, and if I freeze the layers, I freeze this point number. Now notice these point numbers stayed, so I got to get them. That gets all of them. And if I get rid of this elevation here, my spot elevations stay because I put them on different layers. I separated those attribute layers out. I'm going to also freeze those. And now I've got the beginnings of my survey plat that I can go ahead and finish up. And again, I could connect up my sanitary sewers if I knew that they had lines between it. And you can do that as part of the code, or you can simply draw. Let's choose this layer. So sanitary sewer. And we're going to go from this point down to this point and down to this point. And then we can define that layer, which was my sand sewer with a line type that I don't have loaded. Let's see if I've got one available. Oh, shoot me. Let's see one available offhand. Let's see. If I want to change that, good. Whoops, let me go to my annotate menu for a minute, and I'm going to choose this line types, and I'm going to change polyline line type, and I'm going to find that sanitary right there. It looks like it's going to be an SS. Oops. Next, there it is, but I need to make my spacing scalar and my symbol size. That'll be all right. Set a particular text style if I wanted. That'll be fine. And I'll say okay. And so now I choose this, and there's now that particular line type. And if I look at that line type and I see that it's called sanitary 125.008.100, if I put that back to being by layer, because I now have that line type in my drawing, I can choose that as the by layer line type, give it a color, whatever I want. So now I've got these set up accordingly. So now what do I have in my drawing if I wanted to do a surface model of this and do my contours? If I just take a look at this in my 3D viewer, this is what I have. I have all of those points that have elevations. And I've got these lines that were created as break lines, but the fence line and the property line and the power lines, those are not drawn as 3D lines, so they're not going to be part of that. So, and that's by design that I wanted to make those. And I think, did I put two of these? Yeah, I've got two there. So if I then freeze off this 3D break line layer, see now I can see that patterned line for my driveway. I could see this line as my edge of pavement. And maybe it's got a different color than that other one. Let's make that this color. All right, so now, so that would be after I've made my surface, I would freeze off my 3D break lines and use this to be my finished drawing. Okay, now what do I have here? I've got this, that's again, edge of pavement. I've got those X points. So that edge of pavement, I'm getting these X's for my points. So I would go back to my field to finish, set my EPs to not do a symbol. And I shed in my building, I'm just going to leave alone. I'll say exit and okay. So now everything's there. I've got points, I've got trees, I've got all of this stuff in plan features. And if I want to make a contour map of this, remember the first thing I'm going to do is draw a shrink wrap. Go across the gaps. And let's grab everything that we've gotten generated, and that would be the extent of where that would be. Now I'm going to take this particular vertex out because I want the contours to sort of come across a little bit there. And that should be good enough. I'll use that. Again, I'll change that surface boundary so you can, so we know what it is. I'm just giving it some dimension here. And so just like we did before, we triangulate and contour from our surface menu. Oh, I'm going to do one more thing here. I'm going to take this vertex out so I can get back to the tree, back to the fence line. So now if I triangulate and contour, I'm going to give it a name. So I'm going to call this F2F example. Dash EG for existing ground. And I'm going to do a couple of things here. I do have my boundary, so I will use my inclusion, exclusion areas. I'm going to ignore zero elevations. I'm going to densify the break lines because I've got some of those long edges of pavement that I've only got these 2 points on. So it would try to make these giant triangles down here. But if I say densify that break line, and let's give it, say, every 20 feet should be sufficient. And draw my contours. Again, my layers, I'm going to set my contour interval to be 1 foot, 5 foot index. I'll label them every 250 feet and say, make sure there's nothing under selection filtered. I'll say, okay. And it wants me to pick the inclusion parameters. So that's this red boundary. I'm through selecting inclusions. I hit enter. So now it wants me to select exclusions. So I'm going to select these 2 buildings and hit enter. And now I'm going to select all the data to triangulate and contour. And I see that I've generated that, and I've actually got a couple of errors here. Let's see if we can find them. I've got places where break lines cross. One here and one there. There's my distance, my vertical difference of 1/10 and 1/2 tenth. So I'm going to zoom in on that one, and I see right down there, that's where this driveway actually crossed the edge of pavement. And I see the other one is going to probably be that other spot. Let's see. There's that one. There's that one. So it's right in there is what's happened. I'm also going to get rid of this one down here. So now I've got, let me go back and freeze a couple of layers here just to get them out of my way. So I can see that I've got this edge of pavement line, this long, you see the ones where the things are lit up, and it crosses right over top of this driveway lip. So I really need to you know, to have that resolved. I really needed to, instead of having that cross, I should have, when I surveyed this, told that point that instead of that point being PV, I should have made it PV space EP, so it got a portion of that edge of pavement and it coincided with that as a feature. So the simple thing to do is to simply clip out part of the edge of pavement line. So I'm going to break that from here to just there, just to put a little break in it. So I'm going to go to edit and I'm going to break at selected point. So I'm going to break right here and I'm going to break that 3D polyline. Remember, the 2D polyline is at 0. So it's not going to be affected. So now I've got this as a 3D polyline. No, I didn't break it. See, edit, break at selected point. So right there, there we go. I had to finish that up. Oh, except, no, sorry. Let me isolate these two lines so I can. There we go. Now I can edit, break at a point. So I'm going to break here. So now I've got a line, it's just here, and I've got one that goes on to there. So I'm going to repeat that command. I'm just going to break this one back here. So now I'm going to take that one in the middle and just erase it. Okay. Now I'm going to restore my layers. Triangulate and contour again. Making sure that my erase previous is taken care of. Say yes, okay. Yes, okay to overwrite. Select my inclusion. No more inclusions. Set my exclusions, which are these two buildings. No more of those. And now select my data. And now the contours have drawn. They're labeled. It's 500, 505. And if I wanted, I could then go to my V dash. Except I don't. Know what I named it. Oh, topo. All right, so I could change these colors and line types. I'm going to go to my major and I'm going to load up one. If I scroll this down, I think I've got, there I've got contour and contour 2. It's just a little better spacing. So I'm going to set that one to be contour and this one to be contour 2. And I'll set these colors to be, one's a 254 and my minors to be a 252. And so there you can see I've got nice looking existing contours, a 1 foot contour interval. They break at the building, excuse me, they break at the building. And then I can proceed to freeze by pick. I'm going to freeze that layer, the point number there. Everything else is good. Maybe I would at this point freeze the boundary and the 3D break lines. And there now is your finished drawing to that particular point. Okay, now this line, because I froze the break line, remember this line is down at 0, so it was ignored. So just when it crosses here, that's okay. I can leave that there, or I could trim that up if I wanted to as well. In fact, I would just probably do something like select that, trim that like that, and call it a day. Okay. Now, one final little thing on field to finish, and then we'll jump to something else for the next session, is if we look at one of these other sort of advanced features here. If I want to look at that edge of pavement feature, right now it's drawing a 2D polyline and a 3D polyline. And over here on my line type, it's just by layer, that's fine. But notice down here at the bottom, I've got this section that says template. I'm going to show you what this is going to allow. It's going to allow us to, let's say, if I select, oh, I don't have one yet. I need to edit it first, and I want to make a new one called road edge. And we'll put it there in our data set. We'll say open. And so now what I'm going to do is I'm going to define everywhere I walk along that line and give it that 3D definition. It's going to create, I'm going to uncheck this right side, same as left, and I'm going to put in a typical or a potentially typical type of structure. So maybe I'm actually measuring the back of curb. So I'm going to add, and I'm going to go from the point that I survey, I'm going to go flat, 0 slope. I'm going to go out 1/2 foot, or I'm going to say just less than 1/2 foot. And I'm going to call that TC for top of curb. Oops, sorry, I need to move that. I need to be on this side, sorry. So 1/2 foot, top of curb. And then I'm going to add another one that is going to drop 1/2 foot. And it's just going to go at very small distance at 0.05. And I'm going to call that face of curb. And I'm going to add another one here that's going to be at a slope of positive 4% for 2 feet. And that's going to be my EP. So this little white dot up here in the upper left, that's the actual line that I'm surveying. But I'm saying every time I shoot that point, I'm going to draw in 3 dimensions this as a curb structure. I'm going to go out here to be that edge of pavement. Now I can even extend that even further. Now there's arguments for not doing that because the ground doesn't really, it's not really built that consistently. But if I add, say, I'm out now to the edge of pavement. So if I add, again, another percent, I'm going to go only 2% this time. I'm going to go 12 feet out for a lane. That's going to be my center line. And I'm going to add another, this time minus 2% for 12 feet. And that's going to be my other edge of pavement. Oh, sorry, EP2. And we'll just stop it there. All right, so you get the idea. I'm going to save this and say, okay. Now watch what happens with this. When it draws, it's going to create this whole series of 3D lines that look like this. We'll get in here and spin this up, spin it around, and I see that, see, it's going to do a back of curb, a top of curb, a face of curb, the gutter line or the edge of pavement, the center line, and the other edge of pavement, all from just that one point. Now, I do need to break those out of there as they cross that line. So I'm going to do this. I'm going to just draw a temporary line across here and then one across the other side here. Whoops. Oh, 2D. And now I'm going to use that to trim these 3D lines in here. Like this one, and this one, and this one. Then I can get rid of this and this. Don't need them anymore. And let's freeze our point numbers, our elevations, those point numbers. And we should be good to go. I do need to bring back my surf boundary. So if I triangulate and contour that now, same file name, okay to overwrite, select it, select my exclusions, select my data. Oh, sorry. Here's what I did wrong. I need now to take this out to here. Oh, let me just redraw that. Shrink wrap my entities, say okay, get my data. So now I'll pick up the road and I'm going to take out a couple of these in here to give it a little more definition. Hmm. It selected those contours. Now, let's take this guy out here too, just to. All righty, now that should be in good shape. If I triangulate and contour again, select my inclusion, select my exclusions, now select my data. So now when I freeze this, I see that I've got contour lines that actually walk up and down that curb. And let me those going to take a look at this in my 3D viewer. 3D view, drawing viewer. You can see the contour lines, they're at elevation, so they're showing up there. Now, I got this mess of contours in here because we just broke that curb structure, but you can see how those contour lines actually hit the curb, go across it flat, come down the face of the curb, come back up the gutter line, come to the center line, go out to the other edge of pavement. And I'm going to superimpose. I'm going to my model tab and I'm going to choose this add surface, and I'm going to add that surface to there. And you can see there's the exclusions. Down here is the edges that are the break lines. There's that little mess in there that I really, I would resolve that, if I'd done it. But look at the shape of the curbs. You see how that's really defined, and the roadway itself is defined all the way around it. Okay, so it really can help streamline a lot of work for you. So that's actually that's the bulk of what Field to Finish can do in automating what you do, so you're not coming back into the office and having to play, connect the dots, which, a lot of times we do, and we do a mixture of both. And so we just want to keep in mind, how can this help us to get our work done? And so we can see, and there's another example of this contour label being sort of in the wrong place. I'll just move it off there.
Ken,
Yes, sir.
just like the templates, right?
Say
The
that again?
field to finish, just like the templates,
The templates?
designing the drawing templates,
Yes.
the
What?
field to finish. You can also put in the same parameters so that it also become a template for consistency, right?
Well, I mean, yeah, you would want to define your layers and all that kind of stuff in your drawing template. Now, there's two different types of template here that we're talking about. The one where I created this road down here, that was a template, but that's a cross-section template. That's not a drawing template. And that's in this Field to Finish definition of that.
No, I was referring to the first class where James indicated that they are going to send you the drafting specification and the other information to generate a template. Not this session, the first session that we had. Remember? When we went into the settings, the drawing settings and those information that we discussed last, and no, in the first meeting.
Yeah, like all of this stuff.
Yes.
Yeah, where we set all these settings up. Yes. Now, so what is the question? Can I turn that into a drawing template so that the template has all those settings?
No, I'm asking whether the field to finish, for example, for the topo survey, right?
Yes, for Field to Finish.
Yes, like what we just did right now. If the same thing can be done, so that when you bring a data from the field and it's a topo survey.
Right. So to be able to bring it in, yeah, it's not actually defined in the drawing template, this behavior. It's defined in, when we say draw Field to Finish, you see this code table down here where it says where we're going to set to that. We have a particular field file that has those field codes for us. Now it looks like I'm pointed to the wrong table here. It looks like I'm in sheets codes. Nope, let me go back to that. If I, so there, so here's where this is done, is in all of these. These are all the codes that we just got through doing. So we set this up as a file and we save that. And right now it's saved to this F2F example FLD, and we can load that in any other drawing that we want. So you might have one field to finish thing that might set up your contour mapping, and you might have another one that is for a tree survey. Maybe you've got a whole bunch of different tree symbols. And so you're going to use something completely different. And maybe you're not doing any 3D work in there at all. You're just getting locations of trees. So your different code tables are going to be what creates this behavior. And you load those up into any drawing that you want to. Okay,
All right, that's what I was asking for.
did that answer the question? I'm not sure I understood your
Yes,
question
yes,
exactly.
it answers the question, yes.
Yeah, because it's not part of the drawing template. It's part of that code list, or that field to finish code list, okay? And so the way to make that work, of course, in the field is when you're collecting points, you have to make sure you give a description to the point that is in the particular code list that you want to be using. And so that's how that's going to generate there. And as a matter of fact, to give you another real, well, we'll go over this in the morning, or Thursday morning. But there's another way to use field to finish like this. Now, this was to generate, a whole nearly finished complete drawing, just as a matter of, hey, read the codes and create all this stuff, generate my contours, and off I go. But there's another way, and it's going to be a drawing that we're going to look at first thing Thursday, is if we look at this field to finish on the fly. Then this is going to be a drawing once it loads here. Well, I don't guess there's anything in this one. Let's see, man topo, there we go. And now let's draw locate all these points. Okay, so here's a bunch of points, and there's a code 17, a code 18, and a code ground shot. Now we're going to see how that's going to help us to create a better model of this, because if we don't do that, if all we use are the points, you're going to see how there's a big mess in here, and we're going to need to use field to finish sort of on the fly. We're just going to build it on the fly as we go, just for this one particular drawing. And we'll see how that will, help to refine that definition of what we've surveyed. Okay, but we'll take a look at that on Thursday morning. We're actually to the point where we blew right through your afternoon break, so we're going to let you go a little bit early here. But that will just a real quick way to use field to finish just off the cuff. You don't necessarily have to do all this stuff, but hopefully you can see how it can save you some time and effort. But it's going to take a little time to develop the codes and to get used to using them in the field. But once you do, it can save you all kinds of time, because you can wind up, generating your finished product, just like we did here. Now, in this one, I shaded in the road, I smoothed the contours, and I did a couple of different things. But that's basically, that type of preparation that's going to do for you. Now, one last thing to show you real quick. I'm not going to even do it in this particular drawing, but in your data set, there is a there's an entire subsystem in here I want to show you about, just so you can look at this on your own. There's this field to finish quick start guide. There's an easy start and an advanced start document, and it comes with the data files to go with it as well. So if I look at this easy start, now this tells you this is sort of a class on field to finish all by itself. And as you can see, you know, it's quite an extensive explanation of everything. We just don't have time to go through it in, you know, half a day. And see, there's an example of, you know, he drew this entire thing with the buildings and trees and streets and curbs and inlets in the road, you know, all of these different things that he's done. So I'm going to let you take a look at that. There's a thing like using tree codes and sewer codes, utility codes that, you know, is explained down here. These special codes are all explained. It's a really nice set of documents. And up here on the very front page, it tells you these files that you're going to need to load in to configure your system to be able to run these examples. Just make sure when you do that, that you go to your Carlson configure and you save those drawings out to somewhere else so you can reload them back. Okay, just in case. And then there's the easy start. And then here's a more advanced guide that takes you through really, you know, rotated symbols and, you know, how to do things like, you know, take 3 points to shoot a car. Although why you'd survey a car, I don't know exactly, but you know, but all of the things that field to finish can do, which are, you know, just worlds beyond what you had a little taste of today. So don't lose track of that information that is included in your data set that you got. We won't have time to go through it all in this class, but it's all in here under data. There's where we've been working in data sets, but it's this field to finish quick start guide. And that has the 2 PDF files, and it's got the field code libraries that, you know, he's already put those together for you. It's got a coordinate file for you and a real good example of how to run that at really some of those really sophisticated features. Okay. So we'll pick up on Thursday to do that field to finish on the fly, and then we'll wrap up with some other computation and layout commands and other things that we need to wrap up. And maybe computing stakeouts and that sort of thing. Okay. So with
Okay.
that, all right, so I'm going to turn the record.